Eingekommen.
So, hi everyone, everybody. I'm starting this second part of our workshop session. It's called digestion. Why digestion? Because some brave participants, about 20 of them, have dared to cook the past 2 hours in our kitchen. Cooking means they used tools, AI tools, various AI tools, and they had hosts, students from the group I will introduce in a second. And now the idea is that we all come together again and think of how was it, what was our experience, and then also look beyond what does it mean for creative people, creative industries, and creative jobs in the future. First, I'd like to introduce myself again because we have some more participants than in the closed workshop session before. My name is Peter Kabel. I'm teaching professor at Hamburg University of Applied Sciences in the department design. I'm accompanied by a handful of students who will introduce themselves in a second. Together we form a research group called AIX Design. If you are interested in what we are doing, I'm posting the link of our website here, aixdesign.space. We work for about a year now together, and we are researching the influences of AI on design, but also if we speak about design, then this includes all creative industry jobs and areas, be it design, be it arts, be it text, be it visuals, be it sounds, and all these type of things. We did a series of workshops throughout the first half of the year, where we invited international artists and designers who we know that they are working with with AI tools or working in AI. And now in the autumn coming, we intend to do a series of these kitchen meetings where we introduce tools and procedures to people who have no or not a lot of experience with AI tools, because we believe that it's very important for all of us that we really touch those tools, that we not speak about AI, but use AI. But now at that time and that part of the session, we will speak about what we do with AI. So now let me introduce the students. Maybe Sarah, you start, and it would be good if you could just give us a little background. And I mean, maybe I'll open it already. When you started to work together with us, you did not start as a coder or something like that, right? And that's actually a little bit my trick, that I always lure people into things where they do not feel comfortable. And then we see that the outcome is mostly really outstanding. So Sarah, please introduce yourself and then hand over to your colleagues and tell us a little bit about you. I have to maybe wait. I guess you are not able to.
I think now I am.
Okay, good, great, good. Yeah, good.
I'm Sarah. I'm a student and now in my, I think, third year. And when I started, I didn't have any idea about what AI was or what machine learning was. And now I'm starting to get the hang of it. Like, I also started coding a little bit, and I feel really comfortable now with, of course, Runway ML, because that's no code, but now Teachable Machine and what Tom just showed you, that was also really fun and something new for me. And I'm really excited to be here.
Sarah, allow me one additional question. Very often there is this idea of, tomorrow AI will, substitute us. AI will be the creative thing, and we will not do any of the work we have done and enjoyed so far. Is that what you have learned in the past 9 months?
No, definitely not. Rather the opposite, that we can use AI for us, and just everything that now is really like in Photoshop, the selection tool, which is now being so automatic that it gives us time to do something else. So we use AI now for us, and I hope in the future we can use it for us even more, and it will not take away from us.
Good. So then I'll move on to Kim. Kim, why don't you, and by the way, everyone, all the 23 participants of this call, you are really invited to also participate. Yeah, we'll try to make it an interactive session here. Yes, I'm possibly the host, but It's just because I possibly are the oldest here in the room. It's not that I have special competencies to do this. So Kim, why don't you continue and introduce yourself and your journey into AI tools and the like?
Yeah. Hi, my name is Kim, and I'm in the 4th year. And yeah, how I enter AI, it was actually, I started with Peter's course a year ago, and I had no idea about coding. I still have no idea about coding. I'm awful at it, but I will not give up. And actually, the best tools for me was really Runway ML, because I had the time to explore machine learning, what it actually means, and it was quite interesting for me. So, yet I don't think that AI will actually replace us. I think it will support us. We have more time, and I think we can create a lot of stuff with it, things we couldn't imagine for, let's say, 10 years ago. So.
Kim, then there is also, I mean, the question with tools always, do I really have to understand completely Runway ML to enjoy the fruits coming out of it? Or how do you feel about it? I mean, you know, a hammer is also a tool. Do I completely understand the physics of a hammer? And only if I do, I can use the hammer. I mean, tell us a little bit about your thoughts in that respect.
Actually, no, I don't think so. When I think about Runway ML, I compare it always to an App Store, because I have a machine learning application, so it is already trained models there for me. I can work with them, I can combine them. And I think it's quite interesting to understand a little bit about it, that you have a neural network behind it, but that's already, for me, all I know about it, because I can't code a neural network, and this is a complicated part where we go into deep learning and. But actually to use it, no, you don't need to know every detail. I think it's nice to know a little bit about it, but...
Sure, knowledge never hurts, yeah, or it hurts, but it's never a disadvantage. Let's put it that way. Yeah, sure. Thanks, Kim. Let's move on to Tom. Tom, please introduce yourself and tell us a little bit about your journey into AI tools.
Yeah, sure. I'm Tom. I consider myself a creative technologist, and I'm also a student of Peter for quite some time. And I'm looking into AI for a few months, maybe a good year, something like that, 1.5. And as the rest mentioned, I started with no coding knowledge, but then I really developed it, and I worked with tools, I don't know if you know them, like P5 or ML5.js. And because they are open source, I even am now in the position to contribute to those open source projects. So I really got from 0 to hero, maybe not, but 0 to 50% in quite some times, because I learned in these open communities a lot about coding, a lot about machine learning, and how we can use it for the better as well.
Thanks, Tom. How a little bit advanced to Sarah and Kim just in time, because you started a couple of months earlier. Now, if you think of some of those tools, either of them, and the output, how much of a control you have on the output? Can you speak a little bit about this aspect? Because I just tell everyone, when we started AIX Design about 18 months ago, maybe you can tell the story of our trial to develop a logo for it with AI, which was obviously something we tried. So tell a little bit about that, please.
Yeah, sure. So the output is always a question. It always depends, of course, on the model that we are using. But the example you are talking about was the beginning of our research project. We thought, okay, we are have a design background, so we of course need a logo for our research project, and we do it with like we can do it with artificial intelligence very easy. It will be 1 week and then we have the perfect logo. Maybe it will take 5 minutes or something like that. So we thought, okay, we got these GANs, these generative adversarial networks, these networks that can create new pictures. They create pictures and they get sold on Christie's for $500,000, something like that. So it should be easy for it to create a logo. So we just gathered a large data set of logos, put it in there, trained our own GAN model, and we looked up the results on the next day, and it was just blobs. It was looking like paint blobs, like someone threw a paintball on a wall, and that was the logo. And yeah, it is a really good example that it's not done with taking 1 billion logos and just throwing it into a GAN, and then you will expect to have the perfect logo that you will get, like it would be in one class with Apple and BMW. Yeah, it was just a blob. So it told us that the data is really the crucial part here. So you need to look into the data. What kind of logos are you putting in?
Training data.
Yeah, the training data, the training data. Otherwise, you just get like these blobs. So it was really, really interesting to see that on the first try that we had with machine learning.
Yeah, I think this is very important to underline here, that the curation part for us as designers, obviously we get more and more into a role where we are the curators of training data for the machines. Yeah, so that we have to really collect and select the inspiration, so to say, we provide the machine with. So this is a different role as we have it today, because designers and artists today, they consider themselves rather the creative, those who create the stuff, right? So and if we now step one step earlier in the process chain, and we are more the ones who create the training data, and then the actual creation is done by a machine, then it seems to be only a little difference, but it's a big step, right? It's something completely different also in the mindset. Yeah. Let's move on to Bello. Bello, you maybe you introduce yourself as well, and tell us a little bit about your journey. Someone has to unmute Bello. I don't know. Can I do it, or? Yeah, maybe I can do it.
How about now?
Yeah,
okay.
It's working. Yeah, good.
To use the browser because the Zoom app is still converting the recording. Hi, my name is Bello, and I have been working with AI for also now 2 semesters, so a year, with Peter, and I am the classical. I'm the perfect example of Peter's work, where he takes someone who is afraid of AI and code and knows nothing, and then he just somehow kicks you in the butt and tells you that you can do it.
No, I never do. I would never dare to do something like that. I'm just throwing you in the cold water. It's that's brutal. That's kicking you in the butt.
No, he doesn't. Yeah, he doesn't really kick you. He just puts the pool in front of you, and you feel like you can't go back, and then you have to dive in, and then you jump in, and then you realize how fun it is and nice it is to actually swim in the pool, and that it's not so hard to learn swimming. And then over the time, you realize when you look back how far you've come already. And yeah, so this is what happened to me. I had absolutely no experience with AI and was terrified. And I thought, okay, Skynet, Terminator, everything. But then I was kind of hit with reality that it's kind of boring and it will take super long until we actually get there. But in the process, you discover more interesting pieces of like, oh, I can do stuff that was taking a lot of time now very quickly, and then I can focus on other aspects, which kind of sparks creativity. And yeah, so far I think Peter always says this himself. He takes very high goals where he doesn't even know if he can jump that high, but all of a sudden we managed to even surpass these goals, and this has been my journey so far. And yeah, I don't know what else.
I observe in your work very often that you discovered that it's not one tool doing everything for you. You are rather chaining tools, right? Can you speak a little bit about that? Because this was also part of the experiment you offered. I mean, for those who haven't been with us the past 2 hours, we had like 3 tracks, and Sarah and Kim offered 1 track, Tom offered a 2nd track, and Bello the 3rd track. Actually, we thought most of the participants will participate in Sarah's and Kim's track, and only a small number will do with Bello, but it was exactly the opposite. Anyway, speak a little bit about this chaining of tools.
Yeah, so this is exactly what has intrigued me a lot of times, because if we look at AI and we see that AI is amazing at doing one thing, but if you want that amazing AI to do something else, which it is not trained on, it most of the time is not even average. Like, it's most of the time very bad. And so you have to train for every specific thing an AI. So I think it's natural that you try to achieve your goal, make chain one AI to, maybe if we stay in the cooking metaphor, one AI cuts the veggies, the other AI washes it and everything. So you create a chain so that you in the end get the full automation. And I think this is what the ultimate goal of an AI, what we believe AI is, will be, but we're not there yet. And I think at the moment we are still in the field where we try to combine, okay, this AI is very good at classifying, so we let this AI do the classifying, but the other AI is very good at generating. So the classifier tells the generator what to generate. And this is the creative part that I mean. If we try to see, like, what happens if I let someone who's not very good at classifying combined with someone who's very good at classifying talk to someone who's good at generating, and then we change rather these parameters instead of actually changing the real code that we most of the time don't really understand.
Yeah, I think this is very, very important, guys. I have never seen a good chef in a kitchen using a Swiss Army knife to do everything with this one tool. It's simply not working. Yeah. If you look at a good kitchen, then you will see that there is not 20 or 100 knives, but there is a handful of knives and tools. And the cook knows exactly, that there is no way to do everything with one tool. And this is also very, very important learning for creative usage of tools. Don't believe that there is this one tool. Don't expect that this will come around anytime, I guess. Yeah. So rather find out, what can I do with a specific tool with an efficient use of time. Yeah, it might be that you can squeeze out more drops of some of those tools, but then how much time do you have to invest? Yeah, so to get this final last drop out of it, rather be efficient and think of what tools can I chain so that I do what Bello was saying. Have one step with one tool, second step with another tool, and so on. Yeah, and some of those tools might not even have the label AI. Yeah, they might be just regular whatever tools. Yeah, I mean, you, for instance, use Blender and something. Yeah, a Blender, there is not AI written on it. But it is something. It's a space where, like on a platform of a train station, you just someone exits one train and enters the next train, and the platform is called Blender. Yeah, something like that. Think of this analogy. So, guys, this is what we can say now. It becomes even more interactive, and I would be happy to hear one or two or a handful of you who participated in our actual workshops, in the kitchen sessions, what was your impressions? What struck you? What was problematic, and so on? By the way, it's nice that I can read all your names. It's less beautiful that I don't see all your faces. I think after 18 months of pandemic and Zoom calls, we should have learned that the camera is something like a hygienic function to show that you are you and not a machine. So thank you for doing that, Julia. Why don't you just, that's typical, yeah? You start your camera and then Peter points at you and say, why don't you start? No, start. Tell us, how was it?
I have a very big problem with my internet, and it was very hard for me to participate because my internet was very instable and I always had only half of the sentence. So this is why I stopped my camera, and I figured out it was a bit better. I really like to see faces also, so I usually have my camera on. But in this part of Germany, there's not a good internet. So I try something different.
Okay, tell us how you participated in the Bello track, right?
Yes.
Yes. So I mean, you had some
was
technical problems and so on. Yeah, I understand. But is there something you could take with you, except of that technical issues?
Yes, I did, because I'm an artist, and I really like this augmented reality, but I always have the problem that I really like to touch things, and when you are in the internet, in the virtual world, then you can't touch it. And I think it would be funny to like see something and touch something different. And this is what I like to what I really like to learn in this. But my technical problems were so hard that I only there were 8 steps to create something, and I thought I could create something and then put it into my world and then try to touch it. But the things I had in my mind were not, yeah, I could not really do it. So,
okay.
But I think it's a way I can go. And I did step 1.
Yeah, actually, Julia, it's interesting because, when we speak about code, then we are speaking about like material. Code is also material. And yeah, you can't touch it with your physical hands and fingers and so on. But actually, it's like material in a way that it gives something back. There is a feedback you get. Sometimes it's an error. It's the feedback. Sometimes it's something you have expected. Then that is the feedback. But most of the time, the interesting things are when the feedback is something you have not expected. Which are surprising, which are actually errors, happy errors, or something like that. Yeah. So therefore, I think my suggestion would be view it as a material. Yeah. So it's nothing immaterial. It is, yeah, it's behind the screen most of the time, but it has the same features like material has. Yeah? And then the other thing I just can tell you is, I mean, there is robotic, there is all this maker movement, as you possibly know. You can, attach like actuators, like motors or something, yeah, and then it becomes even more funny, obviously. Yeah, so therefore you can bring it back to the material world if you want. Yeah, sure. So anyone else I can invite to give some impressions on the sessions before, or just throw in a topic which we should touch on. Michael, you also were, yeah, good that you raise your hand. Wait, can I? Oh, great, it works. Okay, good.
I just want to say, I was also at Bello's workshop, and I just want to say Bello has done a terrific job. It was an amazing amazing didactical sequence of showing Colab. And I think Colab is a wonderful tool to discover AI with a bit of coding. What we saw during the workshop is, and that I tweeted about, is that half of machine learning is fixing Google Drive path errors. So you exchange, if you take a tool like Colab or some other tools, you exchange some complexity with some other complexity. So now you have to figure out why Google Drive has this super weird path stuff where you, even if you know how to copy files on your computer, you don't know how to copy files to Google Drive because it's so weird, it's so different. But it was so much fun, and I think, again, to Bello, thanks a lot for this amazing tutorial. And I think next time, make it 4 hours. It wouldn't be boring in 4 hours with a break in between, maybe. And then we achieve all the stuff and even more then.
Yeah, as always, we have been too ambitious, but you know, I prefer to be a little bit over ambitious than to fly too low. But you're absolutely right. There is a lot of things which have nothing to do with AI or so. It's just to integrate things, right? But I mean, the nice thing is once you have done it, you have it, yeah. So you can build on that. So this was definitely a little bit too over ambitious. I also was following you guys for some time, and I also thought, well, one of the takeaways for me is we need more time or a little bit less or a little bit preparation, yeah, so that all these things are prepared already, yeah. So that's a learning for us as well. As I said, I mean, this is a test for us also because we intend to do this type of show kitchen in autumn frequently. As I said, please register on our website, and then we will inform you for more of these things to come. The idea behind is to just explain it to everyone else. The idea is a little bit with cooking, yeah. So there is people who say, "Ooh, I'm not able to cook. Yeah, the only thing I can do is open the pizza box and put it in the oven." By preparing things, doing the dirty work already of cooking, yeah. So and have it all prepared for you guys. We hope that everybody is encouraged, yeah, to say, "Ooh, I can cook." Yeah. So even if the dirty part still has to be done beforehand. But we think if you eat something delicious, then you are more motivated to do the dirty part next time than if you just start with the dirty stuff and and then you never reach a point where you get something to eat. Okay.
Really briefly, quick question. There's some user in this call called KYA. Who is sending me sort of harassing messages, so maybe we could kick him or her out.
Okay.
Weird.
That's
like direct.
I'm sorry.
No one can.
I'm sorry for that. I don't see him actually.
Oh,
we'll
maybe
have an eye on it. We'll have an eye on it and kick him out as soon as we see him again. Don't worry.
Okay, great. I'm sorry for that, Maxine.
That's all right.
Okay. Is there anyone else who wants to jump in and raise something or tell about experiences, be it in the workshops or beyond? Maxine, maybe you also can start because you also participated in one of those workshops.
Yeah, sure. So as Michael said, I really enjoyed it because Bella did a fantastic job. And I think I wouldn't have been like, how do you say it? Mutig enough, brave enough to participate if it wasn't for Bello, because I know he's very patient and kind. So I thought, okay, we might as well take the tricky group. And for me, it was really great because I participated today because I think that for young designers, it's very relevant to like touch on these AI subjects because they will be very relevant in the future. And I think it's absolutely necessary to also, if you're not into coding, because I think it's rocket science, I still do, but I think it's very important to just like start looking into it and then discovering that it's maybe parts of it aren't that hard, and you get to know people, you can ask for help in the process. So I think that's great, and I'm looking forward to dive into it more. And yeah, so it was great. Unfortunately, I didn't get to finish, but I'm still happy to have a slightly moving Merkle on my screen. So yeah, some slight successes today. So thanks again, Benno.
Yeah, very good. Actually, the 2 or 3 things I'd like to mention here. First of all, I maybe you should avoid to think of coding as rocket science. Yeah, because who is able to do rocket science? I mean, I am not. Maybe you do, but I'm not. So think of it as something which is really step by step. Yeah, and nobody starts coding from an empty screen. Everybody, even the rocket science coders, uses already existing code snippets and combines it in new ways, yeah, or changes parameters and so on. So therefore, don't think of it as rocket science. Think of it as something you can definitely reach soon. Yeah. See, Sarah, Kim, Bello, Tom, when they started, when they came, I told them, look, it's really beautiful with me. I'm not an asshole. I would never kick your butt. But then next moment, they were already in the pool. And they survive, as you see, even better. They do something that they teach it now. Yeah, and this is also something I like very much. Yeah, so that really learning by teaching. Yeah, another secret. That's exactly what I do. Yeah, I have no idea about anything. I'm just telling people, and teaching them, and that also brings me a step forward. So yeah, but good. And also, I think everybody who was in the workshops knows that you have access to that to the Miro board. So all the resources are there. Yeah, and that's not by accident, but that is really part of our thoughts. Yeah, we think that open source, openness is extremely important. And you can rely also on openness. Yeah. So if you give, then you also will take. You can get all the information. And I think all of them who are in now, be it Tom or Bello or Sarah or Kim, have experienced that if you just shout out in the internet, can someone help me please with this, in brackets, stupid question or problem, you will get answers. That's very nice and very good. And that should be also your mode of operandi, that you also contribute. Yeah. So even if it's only small things. So who else wants to add something, ask questions, or put something in the discussion? I think we have some 20 minutes left. So what nobody of you, I mean, the first track, Sarah and Kim were actually offering, but nobody chose it, was a lot about these text generating systems which are around. Yeah, I think the most crazy thing you can experience is called GPT-3, GPT-3. Go Google for it, try it, or try to get a hand on. It's really amazing. Yeah. So because with GPT-3 you can like speak. Yeah, it will talk to you. And the moment you give GPT-3 some input, some starting points, it will talk to you in really fascinating ways. So try it out. I think this is benchmark these days. It comes from OpenAI, which is this foundation based in Silicon Valley, and they are actually funded by Microsoft, but it's not a Microsoft company. And you can really get some very interesting results out of it. Another thing one should really try out is all these GANs, generative adversarial networks, yeah, which help you to create visuals. So also this is something I would suggest to do. Maybe Tom, you have done a lot of work with GPT-3 and GPT-2. Why don't you speak a little bit about it, and maybe you even can throw in some interesting examples.
Sure. Just one.
Wait a moment, Tom. There is the question, Peter and Sune, can we see some results of your workshop? Yeah. You can do. Maybe first, I'd suggest the following. Tom, you speak a little bit about the GPT models, yeah, and what's going on there. And then next, maybe Bello, because you have also access to the Miro board. You can share the Miro board. Is that good? Okay, great.
Yeah, maybe real quick, GPT-2, so I think it was in the beginning of our research project that it just popped up, and it was really fascinating how good it worked and how good it is at like really basic sentence completion and text generation. So in our speakers thing that we had going on, we always created little intros where GPT-3 was introducing the people, and it was really crazy what came out in the end, because it was like kind of philosophical. And what I'm using right now is something called GitHub Copilot. It's GPT-3 based, and it's working in your code editor, and it will suggest really code for you. You just write a comment, write me a function that calculates the time between today and Christmas 2020, and it will just put out the function. It looked to the training data of complete GitHub and build this thing, and it's just crazy. So I think in this text generation thing and what comes out of it, because if you like to, you can translate everything into text. Yeah, the possibilities are really endless there with GPT-2 and GPT-3.
Yeah, I'm just looking for the URL. I will post it in a second. We have a very interesting master thesis which will be presented next week, but the website is already online. It's from a student of mine, making omelette with AI. So Yongwon, a student originally from Korea, was cooking like hundreds of, was asking GPT-3 to provide recipes. Again, we are back with cooking. Yeah, so recipes. Okay, thanks. Bello has posted it. Go there. It's really, really fascinating. All of those recipes come from GPT, GPT-2, GPT-3. He actually dared to cook it. Yeah, and partly where it was possible, physically possible, he also tried it. Very funny stuff, and it shows how creative and at the same time very structured you can employ those tools. Actually, they are also no code. You just enter a text snippet or a question, and GPT will answer you. Yeah, so this is a tip, I think. Go there. Bello posted it, makingomelette.com. He also runs an Instagram account. It's funny and at the same time very philosophical, because as you know, cooking is also very local, very specific, very cultural based, and so on and so on. So I like the work very, very much. It's the colloquium is next week, so it's a little bit too early to really open it. But since he has published his website already, I can also do it. It's really brand new. Yeah. So now, Bello, just there was this question. I think it was from Verena that she wants to see what people have done. Can you do it?
Yeah, sure. Oh no, the host has to allow.
Yeah, sharing. Wait, maybe I can do this for you. Well, I think you should be able to do it.
Yeah, now it works.
Yeah. Okay. Great. Good.
Okay, so this is our Miro board, and I guess I'll jump onto our results at the moment. Unfortunately, we had not enough time, but 3 people at least succeeded in creating 3D models out of 2D images, and they were in the process of rigging them or animating them for most of the problems were time or internet connection. And yeah, so there you see background removal and also 3D creation out of this. The next step would have been to apply textures on top of that so that it would have looked something like this. But again, we didn't have enough time.
Bello, because I think Verena was not part of the workshop, so maybe it would be a good idea to just tell a little bit what was the goal, what was the steps. It's also interesting because it comes back to that chaining various steps in a daisy chain. Please show that.
Yes. So the idea was you start off with an image, remove the background with an AI model, input the output of the removed image, the image with the background removed into a different algorithm that would create out of it a 3D model. This output we then input into Mixamo, which also has not AI, but it is kind of automatic. So there's some machine learning behind it that automatically rigs the model, the mesh. And once this is done, we have an animated mesh where we can, in Blender, manually, this is a manual step, give the textures. And with this model, this is another manual step, we are able to put our models together and animate them. Maybe one example would be better to show as a video instead. I think this was why people joined my workshop, because I put myself with Angela Merkel in a fighting scene. And basically, most of the participants in the workshop now know how to do this, more or less. And yeah, that's what we basically did. So they are almost, as you see, this is Maxi's example, almost there. And she just had some errors which we would have fixed if we had more time. And the same goes for Michael as well.
Good. Tom, please also show some of the work, or maybe you can, Bello just shares and
I was.
Okay, great.
You can see my.
Yes, we do.
Okay, so we did something that we wanted to implement into Zoom directly, the Zoom Background 3000, and it could do stuff like this or like this. So you can implement that into your Zoom, and it was really easy. So we used this thing called Teachable Machine. You can see it right here. We captured 3 different classes. One is empty, it's just nothing. We did like, I think if I roll out, it's empty, empty, empty. But if I do something like this, then applause comes. And if I do this, whoop, whoop, then a party comes up. And this is then implemented into our program here. This is written in P5.js and ML5.js. And it's a little bit of code, but basically what we are doing, we are just loading the images and loading our classifier. And then if the classifier says party, then we output the party image over our thing. And if we say applause, it puts in this. And I also put in this empty iPhone screen if it's empty. I had a cooking head as well, but yeah, you can try out different things there. And with the help of OBS, we did not do that because it's a little bit too technical and it's quite boring. But I put the tutorial on the Miro board. Then you can just use it as a camera right here. I tried it this morning and it didn't work because you also need to retrain the model. And now it's going crazy because I'm doing stuff that I didn't train on. And really fun, and also a little bit of this chaining logic of Teachable Machine, which is really, really cool and really easy to use with a little bit of code. And then in the end, OBS would be the end. And if you like, I can also show you some stuff. Don't know why half of it is gone now.
I see it on my screen. I think it's
I reloaded the page. So you see some of our participants doing stuff. Kim had some problems with her camera, so she put in this sad cloud. And yeah, we have a lot of stuff going on here. Here it's just saying awesome. And me and Sarah. And yeah, really cool, small workshop, and was really fun working with you.
Great. Is someone from the participants in that workshop still in the call and would be willing to tell a little bit about the experience?
I think Kim and I are the
Yeah, then go ahead. Yes.
For me, it was really cool. I do have a little bit of coding experience, but only so far as like the basics like HTML and CSS. So that's the most I can do. And for me, it was really, really cool because it showed me how easy it actually is, and how easy it is to combine different things. And it's one step further for me now. So I progressed a little bit. I did have a little bit of problems with the editor, but yeah, overall it was great.
Great. So everyone, I think we are coming to an end because I promised that we will be really ready in time, that the next session can start in time. Yes, this was about artificial intelligence. No, we did not speak about the end of the world, the end of creativity. We did not speak about self-driving cars killing innocent grandmothers in the streets. We were not thinking of all this stuff we usually hear if we are talking about AI. We were speaking about daisy chaining little tools and being still in control of everything, of the world, of AI and all of this. It did not take over us. We took over it. And that is exactly what I wanted to be the takeaway for you guys. So please don't hesitate to contact us, because we are out there. Our mission is with Creative Kitchen to bring creative use of AI to as many as possible people in the world of creativity. We are part of this open sharing, so we don't keep things secrets at all. That's not what we do. And I hope that you had some fun and interesting insights. And with that, I'm happy to close this session. And as I said, please contact us if you have any question or further whatever. Yeah, thank you very much for the 3 hours you took with us. And now, Sarah, please go ahead.
Yeah, thank you so much, everyone. That was quite the interesting digestion. And I'm so happy that we had the opportunity to host this workshop as well in the frame of SAAI. So I can't wait what's happening next with the workshop series. And it's going to be very interesting to see what you guys come up with next. And I think a lot of people had fun. There's a lot of comments in the chat about how great it was. So thank you so much for that. And I want to invite you all from the workshop as well to stay in the symposium program if you want. The next workshop is happening at 1 p.m. 1 p.m. and it's by Werner Bogula, and I want to invite you to join if you want. And of course, we want to invite you all as well to join us on GatherTown tonight. I will post the link into the chat as well now to everyone. It's going to happen at 6 p.m. UTC. So yeah, you can join us there. It's a great virtual platform to have a conversation about everything you are interested in, or just chat with one another if you want. So thank you all so much.
Thank you.
Thank you very much, Peter, Kabel, and your team. Thank you very much for that workshop. I hope that all the participants that went into that workshop with a slight idea of a project got some help for starting off with their ideas. And I'm hoping that it also would help you to find your teammates for the project that you're working on. And if you want to get more input, please stay in line with the next workshops. They are also focusing on GPT-2 and GPT-3. They are doing music generation with that, and we will also have some use cases later on with GPT-3 as a dialogue and well, a more philosophical maybe approach to AI. And finally, the panel with the possibility to have some broader questions on this topic. So thank you very much. Please feel free to ask any questions to whom you can get hold on. And if you have questions, also visit GatherTown at the after the concluding panel. If you have any questions, you can also just write to Sarah or myself or whoever. So thank you very much for joining, and thank you very much for preparing that workshop. Thank you.
Hello, everybody.
Hello.
How are you doing?
Good. How are you?
I'm fine. Yeah, I just watched your presentations yesterday. It was really nice.
Thank you.
You did
Yeah.
some cool things there.
Yeah. It was very fun to give the presentation too.
Great. Oh, I see your colleagues also. Anna, hello. Also, your
Hello.
presentation was also very nice on the GANs. Yeah.
Thank you.
I liked it. Yeah. Hello, Sarah.
Hi, great to see you here.
Yeah, I'm also
How are you?
pleased to be. I'm fine. I just want to have a short sound check before the others arrive.
Yeah, I sent you a message through direct chat in the chat. Explaining.
Okay, so I just want to check the music and the playing some streaming from YouTube.
Sure.
So just let's start with this here. Can you hear this?
Yes.
Yeah, loud and clear.
Great, wonderful. So I want to show a little bit about that. And then inside my presentation, I have this video here. Just want to check if you can hear it. Wait a moment. I share my screen. Okay. And to the presentation. Can get there. Like this, okay.
We can hear it, but there's an easier way to do this, Professor.
Excuse me?
There's an easier way to do this with a where you don't have to leave your mic on if needed.
Okay. But it works like this, does it?
It does, but there's an easier way and just makes the audio slightly clearer.
Okay.
Listening. There should be like a bar of options at the very top of your screen with like mute, open video, chat, security, stuff like that.
Okay.
Next to at the very end, there should be like 3 dots.
Mm-hmm.
If you click on the 3 dots, you should see a list.
Mm-hmm.
If you click, there should be an option called share sound.
Okay, I don't see that.
It should be something with sound.
Yeah, but I don't see that here. But never mind. It's just a short interlude, and I want to switch very soon back to talking. So never mind. So
Okay,
I think you can hear it, and it's quite clear. It's okay for me.
Mm-hmm. Okay.
Better to So I don't have to switch back and forth.
Mm-hmm.
Okay.
Yes, the audio is very clear. It's okay.
Audio is okay. Okay. Let's go the easy route. Okay. Hi, Christoph.
How
are you doing? You look stressed out.
Hey, I'm not muted. No, I'm fine.
Yeah, it were some wild 2 days, I think, for you, wasn't it?
Yeah. The first one was really hard.
Yeah.
That was really a lot of excitement. Yeah.
Yeah, I joined your sessions yesterday where the students presented all the models. It was really, really well done. I liked it very much.
Yeah, so that was the team of Mohammed, and they did really a very well prepared.
Great stuff. Yeah. Yeah, it was wonderful. So, when are we about to start? Shall we wait another 5 minutes or?
Yeah, we can wait a few minutes. Normally people start coming in.
Okay, we have some time.
Yeah, we can wait and then we'll begin soon.
Great. I have a nice coffee here, so no problem for me to wait.
Great.
Yeah. So, how did it went for you so far? Did you like it? Liked it, the symposium? I mean, you were busy presenting.
It's been amazing, honestly. It's been a really good experience presenting and listening to all the talks as well as moderating everything. It's been a great learning experience for sure.
Great, great. Yeah, it looks very, very good from this side here. Also, like the prepared collabs and all that stuff. I went along a little bit with some of them, and they're really, really nice. Some of them I didn't even know, like the emotion GAN, which was really fun.
Excellent. I'm so glad you were able to do it in real time.
Yeah, yeah. I also brought some collabs, but I do a little bit in-depth presentation. So I leave the collabs with you because you have to train them for 10, 20,000 epochs that might be might be too long for the for the 1 hour we have today. But I don't know how do you deliver the material? Shall I upload it later to some sort of space or?
Sure. What we did is we uploaded to a GitHub repo, like a repository, or if you'd want to give me the link, I can try uploading it on the main dev posts that we have.
Or we can post it on Slack in one of the many channels we have. You can post it there in like the workshops or something like that in one of the main channels we have.
Maybe I send it to you and you can put it wherever you like it or where you want it. It's just a presentation with some links, and there you can go to the collabs, and I think then everybody can work on them as they like.
Absolutely. I'm sure you're in contact with someone. If you want, I can leave you my email and you can send it to me or anyone.
Okay, great. Okay, so I'm about to prepare now. I think people are dropping in now. Okay, here we go. Shall we start at 3:05 maybe?
Yeah, that's good.
Okay.
Yes.
Okay. Just another minute. I make sure that I have everything in place here. Okay. Oh, here we go. Okay. So.
All right, so I myself would also like to welcome everyone who's joining us today. It's the third day of the SAAI Kickoff Symposium. We already started off fresh with a workshop from Peter Kabel and his students from the University of Applied Science in Hamburg. I'm Sarah. I'm an art history and philosophy student from Hamburg, and I'm going to be guiding you through the event today and assisting you. And I'm going to do that alongside with Isha. She's going to introduce herself now.
Thank you, Sarah. Hi, everyone. For those of you who just joined, my name is Isha. I'm a fourth-year cognitive science and psychology student from the University of Toronto, and I'm delighted to see you all here today. And I'd also like to introduce Arnab, who will be providing the tech support throughout today's event.
Hello, I'm Arnab. I'll be providing tech support and helping Isha and Sarah moderate.
Perfect. Thank you, Arnab. So we will be the people that you can contact if you have any questions. So please feel free to send us a message on Zoom if you have something to ask. And with that, I would like to introduce our next guest speaker, Wagner Bugula. Apologies if I mispronounced your name. Who is a digital enabler at Artificial Intelligence Center Hamburg, or the ARIC. Along with being a digital enabler, Wagner Bugula is a founder and lute player. He has a master's degree in natural language processing and a machine learning certificate from Stanford. His latest projects have been dedicated to AI education at the University of Applied Sciences in Hamburg, as well as AI art within Pismo AI 21. Currently, he implicates his knowledge and passion as an AI enabler at the Artificial Intelligence Center Hamburg, where he also hosts multiple workshops on language, music, and AI, which are all topics we'll get to explore today within his workshop. So thank you once again for joining us, Werner, and the stage is yours.
Thanks, Isha, for the nice introduction. And you also heard my instrument today, the lute. I'm delighted to be invited by Christoph and all of the people who made this symposium possible. And yeah, I'd like to give a short overview about generating music with AI. Let me first share my screen and then start my presentation. Okay, here we go. Okay, can you see this?
Yes, we can.
Oh, fantastic. So I work at the Artificial Intelligence Center in Hamburg. You see here a rendition of our wonderful office done with AI art, of course. And you might know that we did also work with Stahlgan here. The Artificial Intelligence Center in Hamburg is an institution that will help or is some sort of platform between industry, research, and practitioners. And yeah, we engage in several activities around AI. And today we want to go to creative parts of AI, matching the topic of your of today. Generating music with AI is a little bit older project of mine, but I brushed it up a little bit to show you how I got to a music model. Yesterday in the presentations, we already saw some models that you used, but most of these models were pre-created. And I also want to have a little view today on how to create such a model. So to go from the initial data or to generate an idea, use the initial data and create a model. And also I want to discuss a little bit with you about what this means about creativity, randomness, rules in art, and so on. But we will see this later. Music is quite good, and it's a little bit like the art stuff we saw yesterday, because if you see something's generated by an AI, you immediately see if it appeals to you, if it works or doesn't work. Yeah, even I mean, if you have a generative art, sometimes there are some mishaps. Sometimes you count this as creativity. Sometimes you count this as mishaps. It depends on how you watch on it. But this opens a lot of discussions also, and I hope we have some discussions later on. Yeah, you already introduced me, so I don't have to do this again. Thank you, Isha. I want to talk about my instrument a little bit, because probably not everybody is playing the lute every day. There are not so much people anymore who play them. In Germany, there are about 250 lute players. And but the lute is quite quite a traditional instrument, and it reaches back to an antiquity. Even the name derived from the Arabic word al-ud, which seems to mean wood. I'm probably not an Arabic speaker, but it has a lot of connections to this instrument. And in other cultures, like the Arabian or the Turkish culture, we have a lot of lute instruments, even in contemporary music, playing here. I'll give you a little example of two players here, just to get in comparison. So you see these instruments are quite similar, yeah, from how they are shaped and how they are played. They're a little bit different. You see, like the oud is played with a plectrum here, and usually it doesn't have any frets here. Yeah, so the player can slide wherever he wants or she wants. Yeah, but the lute has a lot of bounded frets here. You see, like at a guitar. And you see also the lute is played with fingers and not with a plectrum. So this makes it and made it the perfect instrument for polyphonic music. Yeah, you don't play just one tone, but you could also play chords, you could play double tones and all this. And this made it a very popular instrument in the Renaissance, when European music had a big impact of creativity. And when we look at the European lute, the Renaissance lute, the one that I played here, it was the instrument of choice between 1500 and 1750. And it was for sometimes the instrument that had the biggest repertoire. It had about several thousand pieces, and lots of them you can still find today. What is special about the lute from other instruments is that lute pieces are written down in tablatures. So they are not notated like the classical music score, but it's more like some sort of playing device, yeah, like painting by numbers, yeah, playing by characters here. And it's quite easy to pick up the lute once you have got it here. The piece I played in the beginning is depicted here as a tablature. And you see down here the 6 courses of the lute. And an A always means that this course or string should be played empty, no finger on it, just the empty string. Yeah? The B means you pick on the first fret, yeah, like this here. And then the C means the 2nd fret, D, E, F, G. So it's quite easy to notate it, and it also makes it quite perfect to work for machine learning, because everything is very compactly notated. You have the tones and you have the rhythmic signs on top of it, which is makes it quite easy to work with it and to transfer it to other notation types like MIDI or other number systems. Maybe something about my motivation. As we have seen yesterday, and you all have noticed, that generative AI has become some sort of really big topic in art, video, and music generation. We also want to explore what does it mean for the exploration of classical music, and also what can it contribute to understand the essence of this music. I'm a computer linguist by training, and I'm interested in all the parallels between AI and music and language. And the upcoming presentation after us, the workshop after me, where Tristan will also give us a more in-depth presentation about how he applied a language model to music. My focus in this presentation is not about how to optimize the models and that you can go along in 5 minutes, you can see the results. It's more a little bit of the idea to understand what really happens in these models, and what are the metaphors, what are the ideas that are in there, what are the parallels between the mathematics of the tensor mathematics and the musical thinking. A short overview. I want to give you a little bit an overview about several methods of music generation. Then I want to concentrate on one model, which is quite old for today. It was developed in 2017, but it's still very good to demonstrate everything about music generation. And we want to focus on a special model inside this larger model, the polyphony RNN network. We come to this later. And then we want to test a little bit around with self-generated models. Yeah? Not only the models that are provided on the internet, but how can we get to such a model? Afterwards, I want to have a little side view on other models that are out there to generate music, like the performance RNN, the music autobot, some non-symbolic and acoustic models like OpenAI's Jukebox. You might have heard them, you might have played around with them. Yeah, just to round this up, we want to also have a look at them. let's have a short look about the history of music generation. So this is not totally new and has not come up with AI. It goes back to Mozart. You know, Mozart was a very playful guy. He was always creative and had some fun and played around. He generated something on a piece of paper. He wrote down the several bars of a minuet or of a trio. And he made it this way that the phrases of this and the bars of these music pieces could be combined any way you liked it. Yes, so you had some sort of randomness in there, but the bars were so composed so that they fitted each other. Yeah, and you just took a dice, and then you diced out which one of the 6 bars for or presentations for each bar you wanted to take, and then you got a full song. Yeah, here's a computer-generated model of this. Let's have a look here. I would assume a typical Mozart, yeah, but you could reshuffle everything, yeah. So it takes takes other premeditated realizations of the bars, and you get a different song. Yeah, you get the idea, but this also shows us a little bit that here's a second song. So it shows a little bit that there are some rules in music. You have the melody coming up and going to some sort of end. Yeah, so you have some phrases in music. And also, as we see here, in music generation, we could use randomness. Yeah, we could go this way or that way. We could make it the tone go up and go down. So we are always in between randomness and rules. Yeah? And this is very important for our models here today, because they do apply both of them. I go back to my presentation here. And let's have a look at the possible methods of AI music generation. We have symbolic methods. That means I take some notation, I take some MIDI, I take some tablatures, which is written down and also symbolizes some sort of tone, but it's not the realization of the tone, it's just a symbol for it. And I do processes with sequence generating algorithms like LSTMs or transformers. We will have a look later, yeah, and get another sequence of symbols which represent music here. This is quite good for us because these symbols are very compact. Yeah, we have one symbol for one tone. We don't have to record something. We can just go to the tablatures or go to the musical score. The second method is to use acoustic methods. This is, I take a microphone and I transform everything to a stream of bits and bytes. I have some digitization of the music, and this also transports how the music sounds. Yeah, for the symbolic methods just give us the tone, the height, and the length of it, maybe the impact I have here. But the acoustic methods, like listening to a song on Spotify, is a perfect rounded song. Yeah, and the difference between the two is, of course, the first one is very sparse in data. We don't need so much data for one song. It can be just some kilobytes. Yeah? But the second method, as it specifies everything, how it is performed and how it sounds, takes a lot of data and need a lot of transformation from the analog signal to the digital signal to some sort of representation for machine learning, which makes it rather difficult to work with them. And you need a lot of computation power to work with them. And you sometimes need days to generate a song. We also have hybrid models, just to round this off, where you combine something like this, maybe like acoustic methods and some text you could apply to them, like we have yesterday in the presentations of the clip with a GAN, where we have a GAN that generated an image, and we put some text to it to transform it to something else. So that's something a little bit like this here. Yeah? But we want to concentrate on the symbolic methods because they don't need so much computing power, and you get to results quite quickly. The methods that we want to use here, and the model is called Magenta. It was created in 2017 by Google, and it's still a platform where a lot of people experiment with. And it has a strong focus on music generation, but you could also generate art with it. But I think the musicians dropped in a little bit more here. This comes with several pre-trained networks for rhythm, melody, polyphonic music, and also human-like performance. That means like you have the attack and the agogic of music also encapsulated in models here. These models are quite different. I want to focus on the polyphony model, as lute music is polyphonic music. That means you have chords and you have single notes, you have double and three notes. Yeah, so polyphony model is quite good to represent and generate lute music. A short primer about how we work with these models. On the left side, we see like a well-known beginning of a piano piece, you know, like For Elise from Beethoven, which is a little bit difficult to read for a machine learning model. In the center, we have a MIDI representation about it, which is a little bit more like a digital notation. The MIDI notation itself, to make it a little bit more readable, says, okay, I have a new note starting at point 1 here, or point 0, with a height of 76, which represents the note here, which is an E. And then I go down a little bit to a half tone, then I go up a half tone and down, and so the representation of the music can be done in numbers, and numbers is the perfect food for our machine learning models, we feed these numbers into in Magenta. We feed these numbers into RNNs, recurrent neural networks, which are perfectly fitted to work with sequences. The general idea here is that I put in, let's say, a sequence of sounds, let's say single notes, and I want to predict the next note. So for the training, I present, let's say, the first 3 notes and train it that it predicts the 4th note. And I do this with the whole song and with a whole batch of song and with a whole corpus of music, which takes a lot of computation. But the general idea is to, in the end, get some sort of statistical model that can generate from some scene notes the next note. So the prediction, what is played next. And to make it more creative, because this would be a rather deterministic model, it generates something like the next 3 possible notes with some statistical property to it, and it can select the most accurate or the next accurate. So there's a little bit randomness in it to make it a little bit more fluid. So it selects the best fitting or the second best fitting note, which also might be a good idea. So this is where the creativity comes in. So as I stated before, we have the rule model here, which is generated by the network, because it incorporates the rule how this music is composed in the network weights. And we have a random element here, which makes it creative, because if you play it a second or third time, it can generate more than one song from the material that we have here. It makes it really perfect for experimenting with music generation. Here's some technical details. We don't have to care about this. So the general idea is just shown here. You see, we have some sort of multi-layered network. Usually we have 3 layers between the input and the output layers. And the prediction you see here from the already played note to the next note works through the hidden layers. And the hidden layers, of course, as you know from neural networks, adapt their settings, their weights. And so after batching in, let's say 1,000 times 400 pieces of music, yeah, we have some sort of internal representation of the style of this music. This model might be known because the first appearance of this model was with the Bach bot. I don't know if you have heard about it. Oops, sorry. Why does it switch here? Okay, here we go. It's a model that works with Bach chorals. Bach chorals are very, very strict in their polyphonic setup. And so the rules are quite clear, and the machine learning can learn it quite easy and generate a lot of Bach chorals just from one chord. Here's one example. So we see the model fits quite well with the Bach choral. It has a 4/4 takt, and the sequence, the polyphonic setup sounds quite well. So it's very good, and this model is quite good to generate a lot of Bach chorals. You also see in the end, so it doesn't have any idea of a phrase. Yeah, how a musical phrase starts and ends. It just goes from one chord to the other, to the next, and generates this stuff here. So in the end, you just have to cut it off wherever you like. Yeah, so it's not a holistic model that has a general idea about a musical piece. It just has a statistic model about what happens next. But the results, I think, are quite convincing. Okay, now the first thing that we can do, and that's what we did yesterday, we take a pre-generated model like the Bach model, and we fit it to our new material that we have here. Yeah? Let's have, we have a lute song here now. Stop it right here. And we fit this now to the Bach choral model. And we get something like this here. You might have noticed, so it took the motive, the initial musical motive, and converted it into somewhat of a choral-like presentation. It has a 4/4 beat. Yeah, it has some sort of beginning, middle, and end. Yeah, and yeah, so even this has some charm. Yeah, mashing up things are quite nice, and but the thing that we have here, for some piece it works quite well, and for some piece it doesn't so well. You have a 3/3 piece with a 3 beat and not a 4/4, so it doesn't fit perfectly the choral syntax, and you get a little bit difficulties. Another thing here, this model tries to bend everything to the model of 4/4 chord progression, like a Bach choral, which can go wild. Yeah, here's an example that's really really wild. Yeah, first the motive is played, and then the model jumps in. and so on. You see, of course, it tries everything, especially if you have very, very fast melodies here. It tries to orchestrate everything as a Bach choral, which goes totally berserk here. So what we want to do now is, okay, so the Bach model is not quite fit for our lute music. So we generate our own model from lute music that we already have. Yeah? So the general setup that we have, or the general process is, I get a set of MIDI files. I can go to MIDI world where you have a lot of classical music or pop music. And I would advise, if you want to do this, go for a certain style of music. As you have seen from or heard from the last example, some match well together and some doesn't match well. So don't mix up too much of the material in your training material. So stay with one style probably first to get better results. Maybe later you could mash it up, but it's very disappointing if you have a large corpus with different musical styles and you get to some sort of mash up that doesn't fit anything. The second thing that you could do is to get a music score editing software like MuseScore, which is a free software where you can edit everything. You could play MIDI files in that. You could, if you want to cut out something as an input, that's also very comfortable. Then you have to install the Python Magenta on a server or local machine. You can find everything on Magenta tensorflow.org. And you also find the pre-computed models there, like the polyphony model is already there in the GitHub of the Magenta. If you want to just do a drop in, you could just also use this Colab here, where you can just try out something. Yeah, if you don't want to install anything, or so you just want to try it out. I go later a little bit to it if we have time, and if you have questions on it, we can go through it in the discussion part. But first, let's see how does this pipeline work here. So the first thing that we have to do is to encode the MIDI data into numbers, so to say. So the first process that it's done, it's encoded into one hot vectors. So each bar or each node is just one sequence of zeros and ones, with a lot of zeros and one per column. And you have to convert this into the TensorFlow data format because it needs the data in a certain format. And this is the TF record format. You might have noted if you work with TensorFlow. And once you have it in this format, you can start training with this stuff here. You could also split the training and evaluation sets if you want to find out how good your model develops. And you can also follow up on TensorBoard to see if it is fitting or if it's working for you. The next thing, and that's why we can't do it here, everything today in 1 hour, is you have to train it for some thousand iterations. It needs a lot of material, yeah, to fit it to a good model. Then you evaluate it, maybe you save the model, and when you have the saved model, then you are at the same stage where we were when we used pre-meditated models, because now we can use it to generate music whenever we like. What I took here is I took for my own models 170 pieces of Francisco da Milano, which was one of the greatest lute players of his time. This music is Renaissance music for the 6-course Renaissance lute, and they have all a little bit the same. I wouldn't say the same style, but they are some sort of they have some sort of reconnectable, some sort of certain style. The first model I tried to generate with the polyphony was the 64 by 64 model, and later I tried the 128 by 128, so the larger model. You have to know that choosing the larger model needs a lot of more computing time. So maybe you start with a smaller model and see how it fits, and then if it works for you, or if you see there's something developing, maybe you could go to the bigger models later. It's always the problem of computing power and time that you want to invest here. The results that I had here, and if you do the training, you could follow up with TensorBoard, so you see how the data is how the model develops. You can follow up the accuracy. You could see the loss, how it develops on the model, and you see that if you see if you see down there here, like the you see how many loops you need, how many epochs you have to train here to get some results. After 1,000 loops, the loss starts to go down, and then it converges. No, it doesn't even converge after 10,000 epochs. So you need a lot of loops and epochs to calculate the model. Another thing is, so the models convert after a lot of loops, but when you listen to it afterwards, so you generate something, maybe only 1 out of 10 pieces has some appealing musical elements. We still find a lot of random results, and that's because, I mean, in the beginning, every note can follow every other note. Yeah? After some training, you find out, okay, after a D, there might be an E, there might be an F. Yeah? Maybe there's also a D, so it just repeats the note that was before. And this can also create some rather dull music, like yeah? Something like this, which is not a nice melody, because it doesn't have any concept of melody. It's just how the notes or the chords follow one after the other. You could experiment a little bit with some hyperparameters. So how much randomness you want to put in, they call it temperature here. If you have this temperature really close to a certain parameter, then it follows very strictly the material that you have in the beginning, but it sometimes just repeats the material. Yeah. If you go a little bit higher with the temperature, then it's a little bit freer. So you generate a little bit more free versions of the music. Yeah? It's the same as I told you in the beginning. You have always rules, and you have some sort of randomness here, and you have to find a good way in the middle, yeah, to have appealing results. Yeah, you know this from machine learning, overfitting. Yeah, if you train too much on the same material, so sometimes it tries to adopt, and the material has a certain structure, it tries to adopt perfectly to this material. So it reproduces a lot of this material, but doesn't work well for predicting new material or to work with test material. So usually with machine learning, this is bad, yeah, because the accuracy is not as good, and you have a lot of errors here. With music, sometimes it's good to have some overfitting because it's more to the style of the original material and does not go too far away from it. Yeah, but you have to find some sort of optimum where you have randomness and you have a well-fitted model. Let's go through some cycles along the way. As I said before, it takes a lot of hours to do this, so I calculate everything before, and we just go through it. So the empty model, I have a model that doesn't have any training at all. It's just the blank model you might expect. So everything is connected randomly with everything in this model, and that's exactly how it sounds. Okay, by standards of a free jazzer, of course, this would be regarded as music, but for us as Renaissance composers, probably it's a little bit way off. So then we have something here that's generated with a small model for some thousand. So it has the characteristic of Renaissance music. It has chords and tonal melody progressions, but it has also, you might have heard some errors, yeah, where it is a little bit off here in this tone. Here again, yeah, it goes a little bit jazzy, so to say. It's better than the model that we had before, but still is a little bit off the Renaissance canon, so to say. Yeah, here we have a bigger model with less cycles trained. And this is a perfect song. It would be probably a good pop song also. Oh, sorry. Oops. And it has a lot of elements from the Renaissance music here. Yeah, and the final proof that this works is I cannot play it now because I don't have only parts of the tablature here. You could go and set this back to tablature and give it a lutenist, and he can learn to play it. So it also fits the lute quite well. That's also probably gives you an idea how well it fits the model. Okay, so just one more example I did after working with the Milano stuff here, which is from the early Renaissance. I went to the late Renaissance composer, which has much more complex music. It's more in the Baroque direction and leans a little bit towards Bach from the complexity, of course, and needs a larger model here. So here we have a polyphony model with 256 with 3 layers of 256 units each, which is a large model and needs a lot of training, but gives some very convincing results of John Dowland music. So here we trained this for 15,000 cycles. So this was the motive we fit in. So it has a lot of appeal from the Dowland music, but again, you have a little bit jazzy parts in the middle. And also you have the second part here. Where it fills in another melody that was taken from the material here. It doesn't have to do anything with the material that we had before. So still there's some randomness in here, but it makes it somewhat interesting. And I think if you want to present something like this here, like I did here, you have to do a lot of editing afterwards, some post-processing, to make it really appealing, because again here it has no idea of a whole song where it starts, there's a middle part, there's an end, and how this works, how a cadence works. Yeah, it just fits one chord after the other, have some melodies in between. But even with this, we have I think quite appealing stuff here. Yeah, let me just sum up some observation I have made, and might be good if you want to go deeper in here to think about this here. So as I said before, it has no understanding of musical overall structure. It doesn't know anything about motives. Yeah, it just forward generates without any aim or musical target. Yeah, usually you have a cadence. You go like you go down, and then you start the next phrase. Yeah, this doesn't work this way here. The attention mechanism is static, so it repeats random element from a few bars before. And I think in the next workshop from Tristan that you will have, you will learn a new model like that has an attention that is not fixed, that it does not look back, let's say, to the last 3 chords, but spreads out the attention to a wider range. So if they have a motive in the beginning, maybe you want to repeat it at the end and not just after the motive. Yeah. So this model is quite restricted, but it shows a lot of the mechanics behind it. Yeah, with slow models, with small models and low training cycles, we find, let's say, interesting new styles, yeah, like the jazzy stuff or the free stuff here, yeah, but we don't find any style-proof lute music, yeah, so it diverges very much from the material, yeah. Also here I would recommend to try out bigger models, smaller models, yeah. Don't give up after 1,000 or 2,000 training cycles, yeah. There's still probably interesting things to happen. The good thing about the Magenta model, by the way, is while you are still training, you could already take the model out and use it in a different window, yeah, to generate music with it, yeah. So it works in the background. You could just take the model, let's say after 1,000 cycles, yeah. You could play with it and have it something generating, yeah. But the model in the background still works on, and you can just take the next one as you go. That's also very good for experimenting with it. Maybe we have a short look. You know, we have had a look at the process now. We have a short look how this looks in a Colab notebook I'd like to share with you. Probably we don't have the time to go through all the generating here, yeah. But just you can follow along and try it out yourself. The first thing, of course, we have to install all these packages here, especially the sound generators here. Of course, this takes some time. I already did it here. And then I also prepared this here. You need to prepare some subfolders, because if you want to generate your own model, you need a starting directory for the initial MIDI files, which I called MIDI here. You need, does it still have the runtime? No, it doesn't. Wait a moment. I'll start to reinstall everything in the background and talk along. And we have a look at it later. So you need a MIDI directory where you put the initial MIDI files. You need a MIDI TF directory where you put the converted TensorFlow input data, like the TF records. You need a run directory where you put the model, and you need an out directory to generate the MIDI files. Then, of course, you have to set up your drive, your Google Drive. We had this yesterday, yeah, to connect to your Google Drive where you upload all this stuff here. Then you have to import the Magenta library and all the dependencies like the TensorFlow, the NumPy, and so on. Then you, the first thing, you have to convert the MIDI stuff into the TF record, which is done here. The next thing is you have to create the data set. And you can split it already into the training and the evaluation set here, which is done here. You get a lot of warnings. Don't care for it. It works. It runs through. And here again, you see an explanation about the different parameters you have to attach to the model. Maybe I go along here with the. You know this if you work with Google, you might know this here. So later we have, oops, sorry. We are here. So, and this is the point where you train the model. Yeah, it's already a Python script that is prepared and delivered with the Magenta, and you see here the run directory. Where you put where you have the results, you have the TF record. That is where the prepared training data are in there, and then you just specify the number of training steps, the parameters like the batch size, how large should the model be. You have some other config stuff here, which is all explained above here, and then just have to run it through here. I did it in the morning. It takes some, let's say, 10 minutes, yeah, to just generate maybe the first 50 cycles or so, no, 150 cycles, 160 cycles, and you see the accuracy is not quite good here. If you have a small data set, yeah, the accuracy here is about 26-28%, which is not quite good. You need a lot of material, maybe 100 MIDI files, and you need a lot of maybe some thousand cycles to run through. Yeah, but I leave you with the Colab later, and you will see that will work quite well. You see it here again. Yeah, how many cycles you need here. This is trained with 170 input files, and after 2,000, 3,000, 4,000, 5,000 cycles here, it becomes to get interesting. But this takes some time. Okay. Okay, so much about this here, about this model. You could try it out with the Colab. I also prepared some material you can work on with. And just for the sake of being complete here, of course, there are other models, and I don't go into detail here. This is just one model, and it's very restricted, especially if it comes to performance, because it just generates notes, but has no idea about, let's say, how strong a note is. No agogic, it's in there. It's just one note after the other. And of course, there are other models which are much more sophisticated. The transformer models are very, very interesting. The sequence-to-sequence models, there are a lot of them. And the BERT model also is very interesting. You see all these models come from natural language processing, and try a little bit to play on the similarities between language and music. I mean, it's some sort of metaphorical connectivity here. It does not translate one-to-one, but I mean, a lot of sequence of referring back to something that was said before, well-formed strings, grammar. Yeah, is similar between music and language. Yeah, so I also would advise to work with language models on music material, and we will see with Tristan later. I'm very looking forward to see what you can do with it. Okay, just a little bit more, that you have a little bit more material to play with, because I'm talking and talking and talking here now. The Music Autobot is a model that relies on transformers. Yeah, you know, the transformer model, we had this yesterday already, yeah, has some sort of layers of encoders where the input is transformed into an output layer. And these encoders can be quite complex. Yeah, usually you use some sort of attention mechanism, so that inside the encoder, there are some relations between, let's say, the first and the last node, or the first 3 nodes and the 5th node, which are encoded in the encoder. So it can generate much more complex music than just looking at the last bar and try to predict what is the next tone or the next bar. The Music Autobot I could also recommend is something where you can play around in a browser. You don't have to install anything, yeah, but you get a good idea probably how powerful such a model can be and how it works. I give you the link later. Another thing, also in the Magenta thing, that's a little bit enhancement of the polyphonic stuff here, is the performance RNN, which helps us in generating not only, let's say, note on, note off, like a piano roll. You see here on top, that is what is generated from the Magenta classical polyphonic model, is something like this here, like a piano roll on a mechanical piano. Yeah, it just has a tone on or has it off. Yeah, but a player, a real piano player, has a lot of nuances here. It plays a soft tone, it attacks the tone, it's maybe slurs a little bit. Yeah, it moves, it bends the time, yeah, to make it more interesting. That's symbolized by the color down here. Yeah? And this model is also quite nice. It's trained on piano performances where they not only recorded like the tones that were played, but also the attack. How did the musician, how hard did he hit the key, so to say? Yeah, and this is difficult to get material like this, but Google delivers some meditated material here. It's also probably a good idea to work with this a little bit to get a little bit more human-like performance, so to say. Yeah, the last thing, a totally different way of models, I just want to mention here is non-symbolic, like acoustic models. Here, the input is not symbolic representations of notes or scores, musical scores. It's just the sound signal itself. Yeah? And as I said before, the problem here is the huge amount of data. A typical 4-minute song at a CD quality has over 10 million time steps. Yeah, and it's a very, very, very big model and a lot of cycles you need to devour this. And just remember, to train a model, you just don't need one song, you need hundreds of them. I have to present it maybe 1,000 times to the model. Yeah, so this takes a lot of computation here. The WaveNet is something here I linked here where you can read a little bit up more about this acoustic model. And also like there are some very sophisticated models that tackle the data problem here, like the OpenAI's Jukebox, which takes the raw audio material you see here on the left top, and tries to compress it down into several parts, several patterns inside the music. So from the 44,000 samples above, it compresses it down to 344 samples. Now it has a very narrow expression range, but also does not need so much data. It's like a dimensionality reduction. You might have also applied in machine learning, and then it performs the training on the transformer, and later from the compressed audio it upsamples everything again back to sound files. Yeah, I mean, you see the process is very, very sophisticated, very complicated. Yeah, but with the reduction, so the machine learning model, which is in the middle here, can work with much smaller models and is much more efficient then. This AI jukebox model is trained with 1.2 million songs, 600,000 of which were in English, and also it is paired with lyrics. So we have some sort of hybrid model here already. And they also try to cluster it a little bit so that you have some sort of style-proof material for the beginning, and then it trains with it. I mean, I could not play 1.2 million songs beziehungsweise train this on my Colab or on my laptop here. So, but you can work with a fixed and premeditated material here and try it out. There's a Colab also for this. I don't go into details because it takes a very, very long time to install everything and to also to sample it. Just to give you an idea here, on a V100, which is a big machine learning processor unit, it takes about 3 hours to fully sample 20 seconds of music. With Magenta, you only need 5 seconds. To generate the same. The model size is 11 gigabyte of the jukebox material. The Magenta model is 7 megabyte. Of course, everything is symbolic. You don't have any expression nodes in there. You don't have any, let's say, sound representation. You just have the score, so to say. But I leave you with the jukebox material also to experiment a little bit, just to give you an idea how it sounds. Do we have it here? You see, this was trained for, I don't know, 2 hours. It's 4 seconds of sound and still sounds a bit a little bit shabby. Yeah. So don't try this at home. Try it in a huge data center. Okay. Of course, we have some hybrid models also here. GANs are also very interesting here, where you, let's say, have let's say a representation of a music file that's probably done by Fourier transformations, where you have the whole spectrum of a sound. And you could play this on the spectrum representation here, which is a very nice. It goes very nice into the direction of art reproduction, because you have some sort of artwork here, and you have to represent the next column of this artwork, which represents, let's say, the next representation of the next musical bar that is played here. So there's a lot of connections between these models, and of course, this also takes a lot of time to program and to train on. So let me come to my conclusions here. Those symbolic models like Magenta are easy to use. You have a very good interface for media upload. You could start with a material you would like to use. You also have some pre-trained models here. The first tests I made here are quite good, but still remember the thing I presented here, these are the top results, yeah. And I created about 2,500 songs or pieces, yeah, and only 50 of them were really good. A lot of them is a little boring, yeah. It repeats the stuff here, yeah. You have to really dig deep and have a lot of post editing and curation to get really good stuff. But the things that are good, I think they are really good, yeah. So things you never might have thought of, and they're really style proof. Of course, the generated material can be, again, the input for composing new materials. So what I did is a melody that was generated, I cut out with a music editor and put it as input for the next generation. Yeah, so it works a little bit on the meta level to work with the material that you already have here. Sometimes this works, sometimes it doesn't work. Yeah, it's still experimental. Yeah, more complex music, I would assume Dowland up, and maybe Baroque music, orchestral music probably is need much bigger models. Yeah, and probably so the single Magenta model is not apted to do this well. I give you also the music autobot. You could play a little bit with it. I give you some links to transformer models to play with it. I think then you have a whole range of, you have a good overview now, what models are there. Maybe you got an idea how complicated it is to develop something, also the shortcomings of the models. And maybe you would like to work a little bit with it. I put some links down here. The first thing I describe the whole process on my blog here. It's a two-part blog entry where everything is explained from the bottom up. I have the playlist of the stuff that I generated if you want to listen to more sounds here. Here's the Magenta homepage if you want to dig into it directly. Here's also a nice video from the Magenta team where it is explained again. Here's the music autobot that works with the transformers, and another article about music with transformers. So I would like to thank you for your attention, and hope I could encourage you to work a little bit with the models and do your own experiments with the models I could show you today. Okay. So if there are still questions or we want to discuss a little bit, of course, I have to stop wait a moment, stop my shared screen here. Now I'm back. Yeah, so far, thank you for your attention. Are there any questions, any remarks, any experiences that you already have with music generation?
All right, thank you so much for your insightful talk. We did have a question in the chat. I believe Bella was asking if you could post the Magenta collab link in the chat, but I think you're going to perhaps share the slides with us or share the links eventually.
Of course. I share it directly here. It's here. Yeah.
In the chat.
But also I put it in the material. You get the whole presentation with all the stuff, and then you could play along with it.
Perfect. Thank you so much.
Okay. Any more questions? Any, or maybe also experience that you already have with generation of music? Just if you like to share something, or what are your experiences?
So, maybe I can just ask a very simple question.
Okay.
And maybe I'm getting it the wrong name finally, but there are these very famous compositions, these clap compositions, the minimal music compositions. Is it Steve Reich or something like that, where you will have people? I always wanted to, have that as a training data or using that and to have an AI playing around with that kind of rhythmic architecture. So I was just wondering, I would love to see that or hear that.
Yeah. So Magenta is perfect for this because it has a very good representation of beats, of drums, of rhythm. And there are, if you go to the Magenta page, you will see that a lot of composers and DJs have worked with it, and minimal music would be perfect for it. The problem is to get the training material or the stuff because it's copyrighted, and but you could generate, let's say, some beats very easily from scratch with Magenta. They have also a drum, a polyphonic. A lot of percussion engines also there and models, and I think it's very easy to work with it. I will do some research and put the direct links also into the material. So if you want to try it out later, I definitely know that there's very, very good material for it. Let me just go one step further. I know that there are some research at Sony so that they want to generate this in real time, because what we do here now is we train the model, then we have the model, then we generate, let's say, 10 files, then we curate it, and then we find out that this is quite good. Maybe you have to re-edit it a little bit to make it fit a perfect song structure. But what they want to do is they generated, they have a model and generate everything in real time. And what they want to do is to have this as a background song for gaming. And so they get the feedback from the player. So maybe he or she is excited, playing around in the game. And the music will adapt to this emotions here in real time. Or the scene changes to some, let's say, serene scene, everything is calm, so the music will calm down. And I found this very, very interesting because this is, let's say, some sort of, reminds me of this Blade Runner story where they have this, the original story, where they have this human, how they call it, emotion organ. So this used to be science fiction, but now it comes true. So the music will be adopted to your state of mind. And this is a totally different music idea than we have here. Like, this is a piece, this is a piece of artwork that is, we have to work with. So, but this is generated on the go, on scratch, and it's generated from, let's say, parameters that you put in real time. And I think this also is a very interesting idea because it moves away from the composer in the middle, and it moves towards something that is generated directly out of, let's say, your emotions, your parameters that come from your computer or your Apple Watch or whatever. I think this is also a nice perspective I'd like to add. Yeah. Okay. Any more ideas about that, or any?
One. That's fine. Sorry.
Yeah.
Using the as we were talking about Sony and how like AI can change the music, doing the gameplay and everything. Could we use that in, for example, a film or something like that, where depending, like on Netflix for interactive film, where the music changes according to their choices, stuff like that?
Maybe. I think a game is still very restricted in this options that you have here. It looks quite elaborated, but the thing that you can do even in an open space game, so the options are quite limited. So it's quite easy to generate something. I think film, it's a very, very high level artwork, and I think it needs some time for a director to really do this experiment. I mean, technically, it would be perfectly possible. Probably one step in between would be something I put in the, let's say, some parameters of the film and have something generated with it, and probably then curate it to make it really match, let's say, the idea I want of the film. But I think later on it might be possible that you have, let's say, different soundtracks for different films. Yeah, if you, let's say, a punk rock guy, maybe this film has a punk rock soundtrack. If you're a classical guy, it might have a classical soundtrack. Yeah, whatever. It's a nice perspective, and probably the time is not ripe for it now. But I definitely see this coming. So it's a nice idea.
Thank you.
Yeah, great. Anything else?
We do have a question in the chat by Francesca, I believe. She'd like you to elaborate on training data and copyright issues. If you could just elaborate on that.
Yeah, that's why I chose the Renaissance material. These are about 500 years old and out of copyright. So it's quite easy to work with it, with classical music, also Bach. Yeah, also very nice. I think if you go towards, let's say, modern music, Debussy, maybe, I don't know. Philip Glass definitely has copyright. Yeah, if you work with it, it's still not decided. I think there's a huge army of lawyers who will make a lot of money with questions about this. Because the problem we have here, if I take the material and take it as input material and work on it, it's not let's say a perfect rendition of the material that we had before. So it's just material. And if I'm a creative and take some melody and sample it up, there are still already rules on it, on sampling. How deep does the sample have to be? How long can it be? But I think, it's still not decided. The same thing what about the copyright of the things created here? Because no human has created it, but a computer has created it. Can a computer claim copyrights? And this is still a thing that has to be decided on, because it breaks the rules of our judicial system or law. And I don't have any answer to this, but this might be a good earning perspective for lawyers if you concentrate on things like this. Tristan, you also wanted to ask or contribute something? You're muted.
Okay, there. Thanks. A great talk, by the way. I really loved it. I was glued to the screen here. About the copyright thing, yes, nobody actually really knows for certain. It's like, well, if you have a machine generating something, there is an US American definition of copyright, which, how it is written, only applies to humans. So their guide does not consider any robots, so robots are free to do. Yeah. And what was the other thing? It's also a matter of when does the AI start to generate something that is nothing new, so copies something. There is this the Codex, this AI that programs by OpenAI. It's a tool called Copilot, and they have a rate of, I think, out of all the predictions, 0.1% of all the predictions are like things that already exist. Everything else is just novel stuff. But there are going to be quite a lot of discussions there. But in music, there have always been so many discussions, like how much you can sample. Just to conclude this, there's still this law case going on between a rapper here in Germany and Kraftwerk about 2 seconds of sampled music. Let's see.
Yeah, I think as we all know, when we work with AI, it breaks boundaries. Yeah, it breaks creative boundaries, but it also will break the notions that we have about creation, artist? What is a work of art? What is the law around this? Yeah, like copyright and something like this. I think it's very, very interesting. I mean, you could also, let's say, have let's say a music piece and make it a painting or so. Are there still elements from the music piece in the painting? Can somebody claim that you stole the general structure of it or so? You never know. But it makes it also interesting, yeah, because the whole process of being creative, what makes us humans unique? Yeah, if a machine generates the same stuff that Beethoven probably would have created, is the machine, has it some sort of creativity in there, or is it just coincidence? I mean, you could also have, let's say, have monkeys, doing drippings on a canvas. A lot of them probably would look like Jackson Pollock, but it's not a Jackson Pollock, but probably it's functionally equivalent. I don't know. Yeah, so it's really, really difficult to decide on this. Christoph, you also want to contribute something? How do you think about it? You're still muted. Christoph, you're still muted.
No, I can. Yeah.
Okay.
Yes, I can. So, well, I don't want to elaborate on the copyright issue, but for some reason, no. But it just makes me, what you just said reminded me of one of the last slides that you showed, and that was the one with the a model that is on transforming the sound. So it's not the symbolic model, but it's on, and you see the spectrum of audio signals. Yes, to have your space of audio signals, and you sometimes when you see all these kind of transcriptions into the visual from music, you can think about how does this could be read by a visual a computer vision model that would turn this into art. And so as you just said, well, what is copyright if we are copying music to painting? So it just makes me thinking of that question. Has it been, or I think there has been a new way, many new paths to turn one art into the other. So and like the idea of synesthesia has somehow changed. We knew that before, that people that hear sounds, some people would see colors or other way around. But now we have an AI that would be able to see dancing when you hear, I don't know, pictures or something like that. So I like that very much. So and I would like to have besides this clapping music thing, I would like to have a circle that would just turn around between dancing and picture and text and music and motion and so on, and just recycles everything into the next art domain.
Yeah, I mean, this is also something that breaks boundaries here between the modes. Usually a musician probably is not a good painter and vice versa. There are some geniuses, of course, who can do everything, but now probably somebody has also maybe can get inspiration from it. I have to, let's say, compose some music, generate some art, and get more idea, get some mood from it. And so the process can be much more complex now. Yeah, it's much more, let's say, productive, and probably can also put the creative into the position of creator and curator at the same time. Yeah? So it's a cycle that cycles up ideally to new art forms. And I'm really looking forward what especially you guys and artists will do with this technology. I mean, it was not was not invented for art. Definitely, it was invented probably by the military to translate Russian into American English in the beginning. Yeah, but now it has a lot of very much more peaceful and creative adoptions. Maybe one more thing that's also very, very complex and interesting that's coming up, as you mentioned, dance. Yeah, dance as an art form is also, and look at the Korean boy bands and girl bands like BTS and so. So art is dancing is a very integral part of their performance. Yeah? And I know that they use artificial intelligence to derivate the dancing steps or derive the dancing steps from a performance. They put it into a machine learning model. Let's generate new dancing moves and then try to mimic these dancing moves so that they can make dancing moves nobody would ever imagine. Yeah, but also this. It's also very, very difficult, let's say, law problem here, because I mean, a dancing move like, let's say, the moonwalk, yeah, or the something like this, is a signature probably of a certain dancer. Yeah, if I take it into a machine learning model and make a derivative of it, I'm also some sort of expropriate this artist. Yeah? Also, I mean, another model that comes up is some Israeli company developed it. You don't need any overdubbing for films anymore. Usually in some countries you have let's say American movie and you have subtitled it. In other countries like Germany, you always have it dubbed. Yeah, there's a German speaker who takes everything and tries to lip sync everything in German. Yeah? But there's a new model now that let's say have Robert De Niro talk in German. Yeah, so it's the same voice, the same cadence, the same appearance, and the same sound quality, but it talks in German. So it makes the lip sync synchronized workers. I don't know how you call them in a technical term. Yeah, puts them out of work because it can be done by machine learning. And in Germany, there are a lot of voices which are really famous, like let's say Robert De Niro's voice, Christian Brückner. He himself, yeah, he lends his voice to De Niro, and for us German, this is the voice of De Niro. Yeah, but these models are coming up now, and I think in one direction it enhances the reach of the artist. Now Robert De Niro can talk German, but on other, it probably also destroys some of the structures that we have here, like the translation business and probably the adopted stuff here. But I mean, it's a very, very interesting. Wherever you look, things pop up. And I'm expecting a lot of turmoil and also creative destruction here. Oh, sorry, I'm really talking hot myself here into this topic. Are there anything you want to ask about the model or something you want to contribute? Because I think we're nearing now the end of our session.
Yeah, we are, but we still have a question in the chat from.
Okay, sorry.
No, don't worry. I think we have enough time for that question. Okay. Verena wants to know if you could generate a song based on a dance performance.
Of course. There's several ways to do this. I could, let's say, have. Let's say I have some songs which are, let's say Michael Jackson. Yeah? I have some songs and see some performance of him, and you know that probably know this AI model that's called pose detection. Yeah, it can detect the pose of a human body. It just reduces it to some sort of lines. Yeah, it's usually used to detect yoga positions, but could also used to detect, let's say, the position of a dancer. Yeah, and then you would train the music with these dancing poses one by one and generate a model. Probably it needs a lot of training because you need a lot of reduction of data here. Yeah? But of course, if you have this model and you will put in new music, it could output generate new dancing moves or according dancing moves. Of course, that could be done. Of course, yeah. So you asked the other way around. Could it generate a song based on dance performance? Of course, you could also make this model work in the other way around. Of course, it's just a connection between the two. Sorry, I did get it wrong, but it could also work the other way around. Okay. if there aren't any more questions, probably we have a little break and yeah, tune into the next presentation. I'm very, very looking forward to Tristan's presentation because it goes probably a little bit further than what we did with the Magenta model. And does it start at 16:30 European time, or do we have some break in between?
Yeah, it starts in about 4 minutes, if I'm not.
Oh, okay.
Yeah.
So I will say thank you again. Close down this session here. I prepare the material for you to share and to work on it. If you have questions, my email will be attached and we can stay in contact. So thank you for having the opportunity to do this here. Thank you, Christoph, for the invitation. And yeah, we'll see you in the next session and maybe later on.
All right.
Thank you, Werner.
Okay, thank you very much.
Thank you.
Thank you.
Bye-bye.
Okay, so we can take a 3-minute break while we wait for our next speaker to get ready. Hi, Tristan, would you like to sound check anything? Is there anything you want to run by before you get started?
Yeah, we can just, I think you now see my slides, don't you?
Yes, we do.
Perfect, and sound check. Let's try that one. I think this is going to work out of the box. So 1, 2, 3. So that seems to work, very good. So rock music always works. Goes through all obstacles. Here comes the other one. Let's see if that one works. Perfect. 2021.
Exactly.
Technology seems to work. Great, great, great.
Yeah, the next time we're doing this, we're definitely going to have to adapt Bello's idea of waiting room music. I really enjoyed that. I will definitely implicate that next time.
Yes, I think Werner's models and my models, they can just be like invoked that they generate ad infinitum.
Oh yeah, that would be brilliant.
It should work. I never actually tried it. I know that my AI can compose a lot of bars, but I never let it run like wild in a sense. Just compose and never stop. It should be possible.
Well, all right, it's 4:30. I guess I would still offer like 1 or 2 minutes for people to join in if they have the spontaneous urge to join now. So we'll just wait 1 more minute. All right, so Welcome everyone back to the third day of the symposium. And yeah, I wouldn't wait for so long, but introduce now Tristan Behrens, our next speaker. Dr. Tristan Behrens is an expert in artificial intelligence and deep learning. Having accomplished a diploma in computer science as well as a PhD in artificial intelligence, Tristan Behrens currently works as a hands-on advisor, teacher, mentor, and strategy consultant within the field. Within his work, he focuses on deep learning for natural language processing and image processing, bridging the gap between data and developed neural networks, augmenting human creativity and productivity with AI, and increasing the multiplication of AI knowledge and experiences. Tristan also works as an AI musician, a passion we get to visit and learn about during this workshop today. So thank you, Tristan, for joining us, and the stage is yours.
Most welcome. Thank you very much for the kind introduction, and thanks everyone for being here on this lovely Sunday. Today I'm going to talk about composing cyberpunk metal with GPT-2. GPT-2 could already maybe excite a couple of you because this is one of the big natural language processing deep neural networks, a transformer. And while cyberpunk metal comes from the nature of how my music sounds, it's not really easy to put it into a certain genre. And I'm going to tell you a story about from zero to Spotify using deep neural networks, which is actually a journey from an idea to something published on the internet. I was already introduced. To put it in a nutshell, I usually say that I'm a musician trapped inside the body of a computer scientist. So actually I started programming first and also had a couple of other interests, including art and music. And now I'm in a very happy situation that I can actually merge the creativity and the AI part. Makes me very, very happy. When I did my PhD in artificial intelligence in 2012, it was not really at the horizon because compared to today, 2012 was like dark ages of artificial intelligence. We were not really talking about deep neural networks here in Germany as much as we do right now. And now I see, especially in Germany, but also everywhere in the world, we are talking more and more about deep learning and other approaches in artificial intelligence for creative endeavors. Also, kind invitation, if you like to connect with me, you can just put my name in Google and you find me on Instagram, LinkedIn, and also on YouTube. Happy to connect. Always reach out. If you have a couple of questions and comments, I would be happy to react. Well, I call it like biblical 50 days because coincidentally, my journey started on Easter, ended on Pentecost, which is like 50 days of something happening in the Bible. And it started with that I had the idea of implement a paper that a friend of mine suggested me. It's called MMM. It's about multi-track music generation. I'm gonna talk about that paper later, which I found extremely fascinating because first and foremost, it uses transformers for music and promised to be extremely flexible in composition. So what I did, I implemented that paper. Unfortunately, back then there was no code for it yet. So it was just a paper, but the paper was so well written that I could do that myself. And now if you find on Papers with Code, that paper and the code is actually mine that I've published. So I gave something back to the community. And I implemented it on JSB. We heard it already, Johann Sebastian Bach chorales. It's a data set of approximately 400 chorales by Johann Sebastian Bach. And I also use Hugging Face. It's a very, very nice company that is specialized on transformers for natural language processing. And this whole thing, like implementing this paper on the Johann Sebastian Bach chorale dataset, that was the Easter weekend. It turned out to be extremely comfortable with Hugging Face. And then while continuing my journey, I wanted to go away from this hello world of chorales towards something that maybe not so many people do. So my idea was, well, let's train it on heavy metal music. So setting the bar a little higher. So usually in deep learning, once you start doing something, the first task you do, the most amount of energy and time you invest in the whole data. Deep learning is something where you also spend some time, but it's usually not that much. A couple of years ago, you would spend 80% on the data and 20% on neural networks. Now with software like, for example, Hugging Face, it's up to 90% data and 10% to neural networks. I had to get a big enough data set. and we already heard about sources for getting data sets. I focused on MIDI files, which I'll tell you is already a symbolic transcribed music, so not working with WAV files or MP3s, but on the MIDI files. And also like annotating those files, which subgenre they are in, because there's heavy metal and there are also a couple of subgenres in it, and they differ quite a lot when it comes to how the music sounds. And that, data scientist, this is what data scientists or data engineers especially do quite a lot. It took just maybe 1 or 2 days to get the data and annotate the data. Did not take that much time. It was just me sitting down, writing a couple of scripts, pushing a button, and after a couple of hours, I had the data set up and running. What took a little bit more time was taking the data set, those MIDI files, and map them to something that a natural language processing transformer can understand. So putting it into a text format. But that's just a transformation algorithm. I think also adds to, maybe it was also in these 2 days that I mentioned. And then training a couple of neural networks for experimentation. I didn't do that much hyperparameter tuning. I just took one neural network, but it was more about like the size of a data set that I had to experiment with, fixing a couple of bugs. I tell you, if you do transposition, like going in the pitch up and down, don't do it with the drums. Drums are pitch agnostic, don't do that. Might cost you a couple of euros. But in the end, I would say it was 1 or 2 weeks training neural networks. And the last neural network that I've trained in that time is the one that I'm still using now. And I trained it on 7,000 heavy metal songs, trained it for 4 days, like 4 days on 4 GPUs. Like happily, I'm good friends with a company for NLP, and they gave me access to the cluster, so I could do some training there. I was very, very happy, and I always mentioned them as I did now. So this is for you, Pioneer. Thank you very much for supporting my work. And then, once you have a neural network, it's quite nice. You have something that can predict something, but you still have to bridge a gap between the stuff that the neural network creates and your software for music production. Plus, you also have to put it into something like a tool that provides you some functionality, undoing things, deleting a couple of things, continuing something, doing a couple of buttons. I'm going to show this too today. Implementing Composer tool, just Jupyter notebooks with a couple of widgets, up and running in almost no time. Did not spend that much time on that, but I'm always extending this one to give it more functionality. So today I'm going to show the tool in its current incarnation, which is a little bit more sophisticated than the early one. And then, now comes the big part and the best part. Having the neural network up and running, trained on quite a lot of music, composing and producing 12 songs. Like sitting down and doing the magic, getting notes together, doing something with the notes, turning this into something that I like to hear when it comes to the sound, doing the mixing, doing the mastering, having 12 songs up and running. And then, getting cover art, finding a band name. The band name is Hexagon Machine, actually comes from a dialogue that I had with GPT-2, I think. There's somewhere write with transformer where I could write, and then I gave some description of what the music is going to be about and asked the AI to suggest a couple of names and did some brainstorming together, and Hexagon Machine was the one that stuck. Also finding song names. Usually I just give my song names, my songs numbers, but this time I kind of set the mood. I told GPT-2 again, I have an album, so many songs, it's composed by AI. It has the title Robot Uprising 2021. Please suggest a couple of song titles. And then it said 1, 2, 3, 4, 5. Really worked like a charm. And then, of course, like uploading it to all the platforms, so for our listening pleasures. So you're going to find Hexagon Machine on, I think, everything now, including YouTube. So long story short, 50 days from the idea via the implementing part, doing a couple of experiments, coming up with tools, including composing 50 songs with AI. No, not 50, 12 songs with AI, releasing it to the public. So that's the entire journey. It was quite exciting. After that, I started a second album with all of this in place. The second album, Digital Dawn, just took 2 weeks with 1 week in between where I was on holiday. And I'm now working on a third one, which is going to complete the cycle of 3 AI albums. I think this morning I finished the 9th, and a couple of hours ago I started the 10th song, so I'm still on track with that. Well, it also included a couple of experiments. We already heard about the Johann Sebastian Bach chorales. Again, this is the hello world. If you have a neural network and you'd like to test it, this is where you start. The dataset is freely available on the internet. You don't even have to think about copyright issues because unfortunately Johann Sebastian Bach is long dead. And every time you run into maybe a deep neural network or some generative AI, there is a high chance that this has been trained on that dataset. And after that, second experiment was that I trained it on 1,400 rock songs, which also contained a couple of hundreds, maybe 300 heavy metal songs, where I thought, maybe this is going to be slightly more complicated because, well, the structures are differently, and also the rock and heavy metal music, they contain drums, which you don't have in the music by Johann Sebastian Bach. And when I saw that, just training it on that few amount, 1,400 songs and MIDI files, I saw that it worked. And then I decided, well, okay, let's go bold, grab 7,000 heavy metal songs and just go wild. And this is the whole story. And those experiments in the 50 days. Dataset. I think this is a very, very nice visualization about how my dataset is composed. So those are the 7,000 songs. I sorted them, or I annotated them, or conditioned them on different genres. And those are the genres that are actually in the data set. And the bigger the font, the more data I have. So obviously heavy metal has a sub-genre called heavy metal, but there's also thrash metal. This is what I grew up with, and Metallica and Megadeth and these things. Was quite happy to listen to those in the 90s. Also, little stronger stuff like death metal and black metal is in there. If you would like to have a little bit more glitter, there's glam metal in it, and also metalcore, folk metal, and power metal, and so on and so forth. They all have different variations of how they compose music. But this is, well, how my data set looked like. So there's something hidden for everyone, I think, in it. So everyone that kind of knows about heavy metal should feel at home in that. What I can say is that when it comes to the composing style, like what kind of harmonies they produce, power metal is my favorite. Power metal is not the music that I listen to on an everyday basis. I'm really leaning towards electronic music. But when it comes to the chord progression and the harmonies, power metal was quite nice. If I wanted to have a little bit more erratic, I switched to thrash metal. So they had very, very nice bass lines and then doubled by guitars. I liked it too. And today I started with black metal. So one song that is very black metal-ish. So this is going to be my musical challenge, my musical sacrifice for the next couple of hours, I think. So, but that's that, dataset. And again, dataset is the single instance that is your path to success. If you don't have a big enough and high quality enough dataset, then your whole endeavors are going to fail. Well, next question would be how to actually train a neural network on that. And there we can take a lot of inspiration from our big brother, natural language processing. Natural language processing, quite a lot of use cases, including translation and things like sentiment analysis. And there is one thing that I like a lot, language generation, and usually makes use of a thing called, or a principle called, autoregression. And the idea is that you have a sentence, a piece of text, like for example, Harry Potter, a student at Hogwarts School of Witchcraft and Wizardry is a great. And then you ask the AI, the deep neural network, to predict the next word. And you can imagine that, well, there are only so and so many words that would make sense. For example, wizard, hero, boy. Those are the ones that make sense. And if you have a good enough neural network, statistical model trained on all the works by J.K. Rowling. And fantastic thing is that you can repeat this. So once you've predicted, for example, wizard, you could also feed that into a neural network and predict the next word and the next word and the next word and the next word. And this is how the big neural networks, like for example GPT-2 and 3 work. They are all about, given a couple of words or tokens, predict the next one. In music, well, it's the same. Let's assume we have a couple of notes. Which one is the next note? And we think about, if you have music, We heard this before in Werner's talk. When you have such randomly initialized neural network, you get just noise out of it. And once you put more structure in it by adding musical rules, the whole thing gets more and more harmony. And this is like something that a neural network has to learn over time. And usually the neural network learns this by training on quite a lot of data. So let's continue. We already heard about them, the transformers. Transformers, very new, comparatively new. I mean, we're talking about a paper release at the end of 2017, a code release at the beginning of 2018 with attention is all you need, which was fairly impressive because now it lifted the bar of natural language processing translation very high. And we got a couple of promises that in comparison to other models like recurrent neural networks, LSTMs, prediction is going to be very stable. It can be trained on more data, and also it can model those inter-word relationships way better because it takes very long sequences, and it also trains faster than LSTMs. So what you see here is the original transformer from the Attention is All You Need paper, which, well, if you look at it, inputs and outputs, as a translator, input is a sentence in one language, and the output is a sentence in another language. So you put in a sentence in one language, and it word by word generates the translation. We heard about BERT, which is about language modeling, like which is the missing word, for example, representing texts as vectors. This is the left side of this picture. And GPT-3, I think it's slightly more famous than BERT because of the fear of fake news that we had a couple of months ago, is the right side. So GPT-3 is just an autoregression. It's a neural network that just predicts the next word, and it's fascinating what it actually can do. Well, and a big difference, so I'm switching between GPT-2 and GPT-3. Well, the biggest difference is the size. Because here you see it is on the right side and left side is NX, which tells you that this block is going to be copied. And I think GPT-2 and GPT-3 has an X that is 96. So these are very, very big neural networks that you cannot train at home. You need a cluster for that. Well, continuing, how to represent this in a format that can be used by natural language processing models. Well, this is a Bach chorale. We heard about that. It's music for not so professional people. First and foremost, singing in churches. You have 4 voices: soprano, alto, tenor, and bass. So 2 female voices, 2 male voices. And what you have there is music that can be sung by those people. So it's not too complicated. It's not the magic flute by Mozart. It's something that people can just easily learn and then sing. And the magic behind that music is that it's harmonically very, very sound. So the whole harmonies, the chord progressions, they're very, very sound. So if you look at this, you always, or almost all of the time, you have the basic triads. So if you know about music theory, there they are. It's usually also something that you learn at the beginning when you start composing, like how to harmonize like Johann Sebastian Bach. So you get a melody. What are the missing voices? Here is a representation of the same piece of music, or a piece of the piece of music as a text. So what you can see here, piece start. So this is a word indicating that the piece is about to start. And then track start. Okay, we have multiple tracks. In this case, 1, 2, 3, 4 voices, 4 tracks. And then it says instrument is bass, which points it in the direction. Bass is the lowest voice. It's the red one that we see in that piano roll. From left to right is the time. Top to bottom is the pitches. So this is something that people who are into music can immediately recognize. So what it says here is note on 61. So the note 61, which, well, I have to do the math, what note it actually is that one. And then this time data 4, which means for semiquavers, so one quarter note. That's what you see here, and then it stops. And then the next one starts and it stops, and so on and so forth. So this is the whole red progression of notes here that you see here. And then, of course, it has, well, not of course, here in this case also has an understanding of where a bar starts or where a bar ends. So this music is here 1, 2, 3, 4 bars. And also here at the end is track end and then track start. And in this case, now the blue one starts, the tenor. and would continue like this. So if you have this as a MIDI file, you only have to sit down and write a generator that would take the MIDI file, like take every track out of it, every voice out of it, and put it in that notation. And once you have this notation for all your files, for over almost 400 files, you can throw this into a transformer. Transformer would train on that and would then be able to, for example, compose a single voice, given a voice, compose the next voice, given 3 voices, compose the final voice that is missing. So, but heavy metal, different thing, but as it turned out, same ballpark. Big difference that I already mentioned is that now you have drums, which are like, it's more like events bass, does not really have pitches. It's more like you have a kick drum and a snare and hi-hats and cymbals, different crashes and so on. And the usual structure is, which makes it also a little easier to understand, I think. You have layers of instruments. So you have the bass guitar, dum, 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 playing something in the lower bass regions of the frequencies. And then on top of that, you have stacked usually guitars. Maybe it's 2 left and right. You maybe have a rhythm guitar, you have a solo guitar, you have a melodic guitar, you have it there. And sometimes, and this depends on what kind of music, of what kind of band you listen to, you won't find it in Metallica, but you might find it in Nightwish, that you have something on top of the guitars. For example, some piano or some synthesizer or a couple of strings. Symphonic metal is orchestral music. So plus they squeezed in the guitars, makes it extremely interesting, like harmonizing with an orchestra, your already existing guitar track. So what I did is I restricted it all to, well, if there's something else that is not guitar or bass guitar or drums, then I just call it other and I map it to piano and train on that. So if this is successful, at least I hoped, I could generate drums, I could generate the bass, guitars, as many as I like, and also something like piano on top of it if I like. And also in that order that I decide. So maybe I start with bass, maybe I start with drums, maybe I start with guitar. This is very important because Hugging Face proved to be the biggest time saver. So remember that in these 50 days, I implemented a paper and published the code. And this paper was extremely great for me to read because it just focused on the data representation. So like you take this data, you do these transformations, you put it in that format, quantization and so on and so forth. And then there was like 2 or 3 sentences. I don't think it was an entire paragraph saying, and then you take GPT-2 from Hugging Face with these parameters and then you train. So no whole chapter, no whole section about the neural network architecture, just said, Hugging Face, GPT-2, these are the parameters, go. And then, well, I did it, worked like a charm. I did not do any fine-tuning with the neural network architecture, nothing. Just threw it in and it worked right out of the box, which tells us that we are now on a threshold of like deep learning where you can almost ignore the neural network architecture because those neural networks are quite powerful. Just to show you a little what you have to make sure is when you train a neural network on music or on text, you first have to get a tokenizer, which takes a look at the text and then finds out the tokens, like node on, node off events, piece start, piece end, track end, bar start, bar end, and so on and so forth. And then maps it into a format that the neural network can understand. We heard about this, well, have to be mapped to numbers. And as soon as you have numbers, the neural network can train on that. Continuing, well, with Hugging Face, it's fairly easy to instantiate GPT-2. And here, quite interesting for you, those transformers usually have multiple heads. I used 8 heads in parallel, and the height is just 6. So when you remember the picture we've seen before, the amount of blocks is just 6. And also positions, or NCTX, is almost the same here, is the amount of tokens that I have for one prediction. And it turns out that 1024 is enough to model 4 bars of those 4 instruments that I've mentioned. So drums, bass, guitars, and piano. So that works without problem. I could go up, and I did in one experiment. I went up to 2048 to model 8 bars of music. Turned out that using it as a tool, it did not make a difference. So the 4-bar model was already enough. And then, well, you just train it. And I'm showing you this to show you that it's only data, and then you invoke Hugging Face, and then you can just go, because you don't see the neural network. So I'm trained to really stack layers on top of each other, create neural network architectures, do magic with loss functions and so on and so forth, train neural networks. But here, you just throw in the data and it works. The trainer trains the neural networks, has a couple of arguments, for example, like how many epochs, how many cycles we've heard before. And then a training data set, which is, I think, 90% of my heavy metal music, and then 10% for evaluation to see how good the neural network is on data that it has not trained on. And that's, well, all. So big takeaway here is that when you start with Hugging Face, the world is going to be very easy for you. And also complicated in a sense because your focus is data only. The neural network, it just works. Probability is very high that it works right out of the box. Well, and then this is the most important part for us, is the sampling part. Like, given a neural network, like, generate something in an auto-regression way, if I would take as input ideas here, encode a token sequence, I could just put in p-start, and then I would tell, well, predict something. And if you go back, you can see it right here. If I would just provide p-start, then the neural network would have a high probability of predicting a track start, and then it would pick one of the 4 voices, because the order is something that I changed over time to make it more general. And then it would predict a bass start, and then it would go wild and produce a couple of notes. And after each bar, it would stop, and after 4 bars, it would go to the next track. Also, you could imagine that if you already have a track, maybe some music that you have created, a tiny little melody, and you say, well, this is the guitar, you could ask it, give me drums that fit that guitar, or give me bass that fits the guitar, or give me both, in an order that you have to decide. So it makes it extremely versatile when it comes to using this as a tool. So coming back, generate, something that you can do. A couple of parameters for that. The most important parameter is the temperature. We already heard about that. If you have a low temperature, then the degree of randomness is very low. And when it comes to harmony in music, if you have one note or you have a sequence of notes, not all the notes that are possible actually make sense. So there are a couple of intervals that sound nice, intervals that you usually avoid. So, and the best note that would follow after a note is the note itself. Because this is, from the harmony point of view, the best harmony you can get, just repeating the note. So if you go down, then the whole thing is going to be very, very predictive. And it's not going to do any musical or melodic experiments. Here, temperature is 0.9. In my work, I usually have 1, and sometimes I go up to 1.25, so adding some randomness to that. The higher the temperature, the higher is the randomness, and the more errors you would get. But errors in creativity, we know, we're always happy accidents, could also boost your creativity. So it's not that bad. So you have to find your temperature that works like today for you, like according to your mood, and there you go. But this is not a thing that I usually change that much. I usually stick to 1 and it works like a charm. Well, custom composer tool is a screenshot, but I have it here as well. As what I've said is that, well, you could invoke the neural network all the time and have some fun with it, but I would like to have some control on it. Like, for example, I could compose all, those are the 4 voices, say all. It takes a couple of seconds, guitar, other, bass, drums. And then you say, okay, that's something. I'll just play it. That's okay. There's a little piano in it on top of that, just those chords. There's a guitar playing something. The bass is really, really reliable, not doing that much, and there's a drum beat underneath it. And maybe I don't like the piano yet, so I say, well, let's give me more piano. And then it does something like here, and I can immediately see, I don't think I'm going to like that. So I do another generation, and I say, okay, let's start like this. What is it? Just going down, but then I say, okay, maybe this is already inspiring to a certain degree. And you remember we heard just in the last talk we heard about this musical dice game by Mozart, where you throw a dice and you get something. Here you would also throw a dice and get some heavy metal music, but the dice has like infinitely many sides. So it's very, very random. You can imagine that you can throw a dice and continue and continue and continue, and the song would get longer and longer. So what I also have here is a go wild button. I still did not manage to turn it into red, but what it does is for a couple of bars, it just continues composition. So I hit it, fingers crossed that it will not destroy anything, and it adds, in this case, 4 more bars, because I want to demo it without you waiting a couple of minutes. I usually start with 4 bars, and then I hit the button and generate 36 more. That takes 1-2 minutes. And then you have a little bit more music. You can see, well, let's listen. So now it's getting really crazy. Now I'm curious what is coming next. Let's go wild a little more. And it already hints at like how composing with AI could work in that scenario. Because this is going to be very crazy. I like that. It's always at the beginning I was extremely hesitant using the material, but then I found out that sometimes AI does these happy accidents, and it really, really inspires me. So this looks, this is very erratic. I like that. So let's listen to that again. Crazy. And this is what I really, really like. Sometimes it generates something that is quite useful. Sometimes you get these things, but every time you get something, you can turn it into something even better. So, and you can easily imagine that, well, I compose 40 bars this way. I find the first 4, and if I like the first 4, I think feeling is good. Then I say, well, compose 36 more. I let it run for a couple of minutes, fetch a glass of water, come back, and then I have something. And this is where like the good part for me starts, because now it gets really, really creative. And what we have learned from Werner's talk is that those neural networks, as great as they are, they have a lot of problems being consistent when it comes to arranging the whole thing. Like, it could be the case that it generates something that sounds like a verse, where you could think, okay, there you could put some vocals, and then it would do like 1 bar bridge and a pre-chorus, and then comes the chorus. But it never comes back to the verse part. It's not repeating itself. So what it can really do on a very close-up, harmonies per bar are excellent. Also, the harmonies between bars are excellent. So if you have 1 bar and the next bar, they are harmonically sound, but it's not repeating itself. And this is something that we humans actually like. If you have just the music meandering through possibility space, not really repeating itself, then we get bored immediately, and then we don't like that. That's the elevator music, that the moodsuck, that we actually do not like that much. And this is where we see that this is not composing by AI. So it's not that the AI creates something and then I put it on Spotify. It's composing with AI. So I get something from the AI, and then I turn it into some better music. So let me show you. This is a fine example of something that the AI spat out. I think maybe it was on Friday or something. So I used the tool, I let it go wild with the button, and then it composed something, and I'll show you a couple of things in it. So again, what you hear is very consistent, but it's just meandering. It's not coming back to things that make sense. And I usually consider this as a huge like treasure trove of inspiration. So I take a look at these files, and then I find out, and I look for stuff that I like, and I think maybe this would be a very good chorus. This would be a nice verse. And then I, for example, find that one. And I kind of like that one here. And then I get a certain feeling, like a hunch that this might be something really, really good. And then I see if it does it repeat well. One more time. Very nice. So I already found something that I could work with. So you can easily imagine that I would take this whole thing that the neural network has created and I chop it into pieces, and maybe I change a couple of things, and then I glue the pieces back together in a thing, like something that makes sense in my world. What I actually almost never change are wrong notes. Like if you listen to a piece of music and there's one note which is off, get this cringy feeling. Never with this. I had this with LSTMs when I trained LSTMs like last year. Always something where I think, oh, this is not so nice, like gives me goosebumps. I have to change that one note. Never with those transformers. Sometimes, because I did not change the format on training yet, sometimes it changes the key. It modulates. So it maybe goes from A to E, because still neighboring and it still makes sense, and then maybe it goes back if it likes, or goes to some other key. And I usually like to, I'm a very simple person. I would like to have 4/4, like, this is the beat that I like. And also, when it comes to keys, I would like to have one key in one song. I almost never modulate when I compose. So that said, this is the music that comes from the neural network. And you see there's this creative process of editing. And when you think about creativity, for example, when writing things, you can make a big distinction between like being creative in a sense that you write something down, and then being creative in a sense that you edit the whole things. And people who teach you how to write say that first you write everything down, you ignore style, you don't want to make it beautiful, you just want to get your ideas on a paper. And then you switch to the other mode, where you edit the whole thing and make it beautiful. And well, people researched and found out it's two different pieces of your brain that you're actually using, and don't oscillate between them, have one and then have the other one. For me, getting creative ideas is pushing a button. Like, okay, it's just pushing a button after 50 days of work, getting the whole thing set up. And then it goes into the editing mode. And the editing mode is where I have the highest degree of creativity. So if I end up with something, usually it's a lot from the neural network. Sometimes I add a couple of nodes, sometimes I remove a couple of nodes, but usually it's that material. So let me show you. I have another one here. This is an example of, like, I took the MIDI file you saw and I found something, and here it's already arranged in a sense that, well, this is something that I'm going to turn into a song. It's the same piece of music that you heard before, but it's slightly cleaned up, and I mapped everything to piano to not to get distracted too much by the heavy metal sound. And this is where you see it all the time, that the harmonies really make sense. So although for the untrained ear, heavy metal seems not to be that sophisticated, when it comes to the harmonies, it's very comparable to classical music. So let me show you, like, moving from one thing to another. Now comes the thing again. And this is like a pre-arrangement, like everything cleaned up and chopped into pieces. And then I create another file. And this is the one that is the song, actually, where I assign instruments to it. So I'm not a real fan of using real guitars here. So what I use here are synthesizers. And then you get something that is like way more electronically sounding. So with everything in it, decorations, adding a couple of synthesizers that just do some atmospheric stuff, starting with an intro here at the beginning, speeding up the whole song, having a couple of things that actually repeat, and then the outro. And this is then something that I would put into a WAV file and master and then publish. This is like starting from a deep neural network, composing something, and then I work. And as you might already have noticed, that I'm a huge fan of actually composing with the AI. So I'm repeating myself here. I'm not really aiming at getting an AI where I just push a button and like a couple of minutes later I have a song that I can put to Spotify. No, I'm very creative. I would like to get some ideas and work with those ideas and turn those ideas into songs. I would like to throw the dice and have something sophisticated that gives me pieces of music. And how it feels like is, well, it's 7,000 songs, so it's a couple of hundred musicians that I actually do jam sessions with, because all those musical ideas that those musicians published, I have there, and say, give me something else. And then maybe something that is inspired by Metallica with a little Pantera in it, maybe a little black metal on the side. And I get all these things. And this also tells you that there's one thing that I, as a creative being, I'm not suffering from. It's creative block. I don't have that. Writer's block is a thing of the past, because I never have an empty piece of paper. So I just click a button and I get something. There you go. And then I change those things around, I edit it, and well, I get a lot of songs. And when it comes to like how much time the whole thing costs, the whole composing part was, when it comes to like really the time, is cut in half. So usually when I spend a good strong 8-hour day on one piece of music, now it's 4 hours. And it really removes a couple of things that I actually don't like to do all the time, like clicking the drums, like from scratch, those drums. I don't like that. Finding someone else. No. I get everything. It's already consistent, a couple of voices, including bars, including drums, and I continue from there. So very nice. So we saw the composer tool and production in Logic. Very important, standing on the shoulders of giants. So I did quite a lot of experiments with different neural networks. So I created and trained neural networks from scratch for music. I think on my YouTube channel, you can see me composing things with the LSTMs and did experiments with TonicNet and Bachbot. I had very, very good experiences with Magenta, which we already heard about. It's very, very strong, especially the music VAE, which I really love, because then you can do math with pieces of music. And it even has a model that works with multiple instruments at the same time, so that you get a melody and a bass and drums, I think. Did not work for my music because I had different ideas. Magenta is very good for initial experiments, but if you have too crazy ideas, then you have to really take it apart and then reassemble it. And my ideas were a little bit too crazy. But that said, MMM, Exploring Conditional Multitrack Music Generation with the Transformer, is like a manual how to take MIDI files and map them to something that you can then feed into GPT-3 or GPT-2 for training. Perfect thing. By Jeff Enns and Philippe Pasquier, they are thinking about publishing their code, but they kind of said it's not ready yet for the public. If you find the implementation on Papers with Code, is actually my implementation, MMMJSB, which gives you like how to train GPT-2 on the chorales by Johann Sebastian Bach with the mapping from the music to something that the AI can understand. So the only thing that, well, thinking about what you have to do if you would like to do similar exercises, the only thing that you have to do is find your data and map the data to the text format that is in here. And then you can just go wild. It has training. I think training on Google Colab takes, I think, an hour or something. It's not as demanding as the heavy metal stuff because, well, here 400 chorales, heavy metal 7,000. So it's quite a lot of, well, it's more material. And then if you have it trained, you get a model and you can run a sample here and get some music out of it. Like really works out of the box. And also a little advertisement for what I have done. If you follow the links, and I think I'm going to send you the slides as well, easier for you to click, and maybe I'll copy paste a couple of things here. There are available the Würzburg winter chorales. So I live here in the beautiful town of Würzburg, and in like last Christmas vacation, I had some time and I trained some neural network, TonicNet, on the Bach chorales and used that neural network to compose an entire album of chorales. This was composing by AI. So with all the positive and negative things, composing with AI, Hexagon Machine, those 2 albums, Robot Uprising and Digital Dawn, are available now. I'm now working on New Order. Well, the names are all made up by AI, which, well, it tells you that those natural language processing AIs have some bias towards negative interpretations of everything that has to do with artificial intelligence, which I do not share. So you're all invited. Well, that's it. Thank you very much for listening. I hope I could inspire you a little. Again, if you'd like to reach out, just feel free. Add me everywhere. And if you have questions about AI generating music, just feel free to ask. I'm happy to talk a lot about these things. Thank you.
All right, thank you so much for your talk. It was very inspiring, and I'm sure everyone has learned something incredible from it that they can apply to their project. So once again, thank you so much for joining us today.
Thank you very much for this opportunity. It's a lot of fun.
So we do have about 13 minutes or so until the next talk. So if you'd like any, there's any questions that you'd like to ask, that would be great. Anybody, because we do have some time until the next talk begins. Yes, we do have a question. Wagner Bugula, please.
Yeah, hi, Tristan. It was a really great, great stuff you did at the opposite end of my work from the musical style. But as you said, heavy metal and classical music have a lot in common. Yeah, that's really great.
Really a lot.
Yeah, fantastic. I just want to ask, as you have more experience with this, have you any ideas how to tackle the idea of musical structure of the whole song or so? I mean, like the verse, refrain stuff, or like the idea of the cadence and so on. Because you can make it as long as you like. It always predicts. It only looks ahead. It doesn't see it from the end, so to say.
Yeah. The problem with the transformer is, although it works on long sequences, those sequences are not long enough. So if we would have a transformer with a big window that could fit an entire song, with all the notes in between, then I think it would do choruses and verses and so on and so forth. But, well, those are computationally expensive. We have to wait for a couple of years until we have the really, really big sequences. But 2 things. People are working on recurrent versions of transformers, where you have still a big window, where you see all the notes, but you also have a hidden vector of something before, for priming the whole thing. And it's one of, I think, recent releases by the Magenta people, where they have this music VAE, where you have the latent space, and well, so VAE, you have some latent space, and it has some, I think, some flow machine or something that would navigate through the latent space and use the navigation to compose songs out of it. So I think we're fairly close to solving the problem. So yes, this whole new approach by Magenta, which I cannot remember, but if you look it up, you'll see it immediately, is one of the recent publications. They getting closer to that.
Very good. Thank you.
Are there any other questions? You can ask them in the chat and I can relay them to the speaker.
Play us more of the happy accidents. Yeah. Since you liked it, I will just quickly share my screen and we do another happy accident there. And yeah, here comes the screen. So there you go. So where is it? Composer. And now I just go wild, clear everything. And let's take something, black metal. Black metal, something that I could listen to for a couple of minutes and then I get anxiety. So compose all. Seems to work. Doesn't look that bad. Let's see what kind of rhythm we have here. It's not as evil as expected. Okay, and let's do the go wild again. Then we can conclude this demo. Yeah, and this is, again, what I find extremely fascinating, because it bombards me with quite a lot of musical ideas. And when I said that my problem is not that I have not enough ideas, it's the other way around. So what I learned when I started implementing this tool, the most important button is the save button. Because already while programming the whole thing, there might be a very, very nice idea, and I don't want the idea to be lost. So I'll save it to a file, and there you go. So concluded, let's just listen to it. So there you go. Another happy accident. I think it's a term used by Bob Ross when painting oil paintings, and then kind of move the brush and something happened. Oh, let's turn this into a tree. I like this a lot.
Before we, oh, sorry.
Okay, go ahead.
Before we proceed with the questions in the chat, there is a raised hand. If I hopefully I pronounce your name right. I think it's Shima. So go ahead.
Shima. Hi. I wanted to ask do you train on different instruments alone, or do you train on all of them at once? Or do you train on just music and then just choose different instruments at the end?
Well, it's what I train on is 4 bars, and 4 bars with usually 4 tracks. No, it's the other way around. It's 4 tracks and each has 4 bars. So this is like the structure of that. And what I do in order to make it very general in composition, I randomly switch or swap the order of the instruments. So it might be the case that one sample would start with drums and end with piano, another would start with piano and have guitars and then end with drums. Mm-hmm. This trains the neural network. The generality that, for example, you could provide guitar and you could ask it, given that guitar, give me the drum, or the other way around. This is a very, very good trick. So I have this data augmentation part at the beginning where I take these things and just swap them around randomly, and it really, really helps. If I would just train in the order drums, bass, guitars, piano, it would only be able to create them in that order.
Definitely.
Yeah.
Do you have your GitHub account where we can look at more examples?
Well, the thing that is available is the GitHub account for the Johann Sebastian Bach chorales. So you are all invited to use that. What I'm actually not really publishing is the whole heavy metal stuff for reasons because, well, I could think about putting this into a product and I don't want to release the product prematurely.
All right. Thank you.
Welcome. Great question.
We do have some questions in the chat. So Francesca, she's asking, apparently the data training has no directionality, but would it be possible training with time directionality, considering music evolution across time, and get the next music style?
Ooh, yes and no. This exercise is already an exercise in like condition generation. So I could tell it now thrash metal, if you train on more pop music, what about more folk music and so on and so forth, if we do that. You could also like train it on multiple like time periods. So at the beginning you have P start and then say period is Baroque. And then it would like conditionally generate Baroque music. But the trouble is with those neural networks or with all of the statistical learning methods that we have, they are very good at interpolating, but not good at extrapolating, like really predicting what's next. So if I train it on heavy metal, I'm stuck to heavy metal. Fortunately, as we already found out, there are so many, like it's so harmonious, so many great rules in it that you can cover a couple of other genres as well, getting very close to classical music. So if you have the harmonization with Johann Sebastian Bach, that model can do a similar harmonization. I've seen this in action. It doesn't happen all the time, but it happens sometimes. So, but well, there is like one class of entity that is really responsible of going to the next level, and I hope is going to be the humans that may use one of or a couple of those neural networks to create new styles, and then we would get more data to train on. But that said, interpolating works like a charm. Extrapolating, predicting what is the next kind of hip hop music, I doubt it.
Thank you. We do have another question. Bello asked about the data set. Did you just collect as many heavy metal songs as possible and then label them, or did you look for specific data first?
Well, the good thing is, well, I got quite a lot of MIDI files. If you look it up, there's, for example, a Lach dataset, which is, I think, Indian for quite a lot. It has 200,000 songs in it, and you can like find out which is the singer or the interpret, which is the band behind that, and you can find out what genre it is. So those are readily available. The only kind of annotation that I did was actually finding out, given a song by a band, what kind of heavy metal is it. Label data, well, it's an auto-regression. This is called self-supervised learning. It's a good thing I don't have to come up with the labels. So everything just went automatically. So I never looked up a file and said, okay, this is that and that. Even like things like people do like this conditioning on keys, finding out which key a piece of music is in. This is an algorithm that you can use. So yes, long story short, it is just finding a lot of data and training on it.
And Shaima is asking, did you try training with music that has lyrics in it? Or on music with lyrics, yeah.
There were a couple of prototypes when I did the first album. I didn't mention it on the slides. I had 1 or 2 songs that actually had lyrics in it, so vocals. The lyrics were generated by GPT something fine-tuned on lyrics by different bands. So it's somewhere available on the internet. Maybe it's called Rocknet. I can't remember. So it generated text, which I kind of liked. But my thing was that I didn't want to mix like human sung voice with the artificially generated music. I'm currently working on that. I have this little cooperation with NVIDIA where I use Flowtron, which is a speech synthesis, to generate pieces of vocals and then put them in, but still in the early prototyping phase.
Are there any other questions? No? All right. Thank you so much for your time and your presentation. We enjoyed it thoroughly. It was wonderful and very creative. Thank you.
Very appreciated. Thank you very much.
Thank you. All right, so the next talk, actually it'll begin in about 30 minutes. So I suggest we could take a break for 30 minutes and then we'll come back for a short 30-minute talk by our next speaker, Sean Blacksfit. So thank you everyone for sticking with us, and we'll take a 30-minute break. Thank you. Hi, everyone. I suggest waiting for just a few more minutes because people are joining. Maybe a minute or so, and then we'll get started. All right. Hello, everyone. So for those of you who are joining, my name is Isha, and I'll be moderating the last talk of the SAA Factory International Symposium. With that being said, please do remember that we will be hosting a panel at 5 p.m. UTC time, so please do join that. And now it is my pleasure to introduce our final speaker, Sean Blacksfit. I hope I pronounced your name correctly. If I didn't, then you can just clarify that later. All right, so Sean Blacksfit is the CEO and co-founder of Dara Network, the community platform for changemakers and institutions that support them. Dara is a video-first messaging alternative to Slack and LinkedIn to help arts, culture, education, and philanthropic organizations build community among their members and alumni. Sean previously headed partnerships and growth for Marco Polo, the video chat app. Earlier, he was the founder and CEO of babajob.com, India's largest digital job marketplace for the aspiring labor, with over 8.5 million users, and acquired by Quicker, you can also correct me if I'm wrong there, in June 2017. Sean moved to Bangalore in 2004 as the third founding member of Microsoft Research India and was a program manager in the user experience teams of Office and Windows. He also was a White House intern with President Clinton's Internet Policy czar, Ira Magaziner. Sean is a TED Fellow, GES Entrepreneur, Unreasonable Goals Entrepreneur, and recipient of the Nama Bangalore Award for Best Foreign Resident. He holds 29 patents, degrees in computer science and public policy from Brown University, and writes for the World Bank and others. Sean lives in Seattle and Bangalore, India, and is married to Archana Prasad, co-founder of Dara Network and the Bangalore Fantastic Tech Art Festival. They share a wonderful son, Vyom, a love of music, architecture, and tech art, and 2 street dogs named Berlin and Madurai. All right, thank you so much for joining us, Sean, and the stage is all yours.
Thank you for having me, and thank you, Christoph, for the invite. It's great to be here. I'm really happy to show off something that we've been working on, and Christoph has been one of the participants for the last few months inside of Dara. It's kind of an interesting tech art project. And so I'll walk you guys through that, and I would love to hear kind of feedback from you guys, and then hopefully we end this with future ways that we might be able to work together and collaborate as an artistic community, and in the hopes of democratizing many of these AI tools to a much broader audience. And so I'll try to give you a sense of what I mean by that. So just give me a moment while I try to share my screen. Are you guys seeing the presentation?
No, I believe we see your desktop.
Oh, okay, that's not the right one. Well, multi-monitors, man, I'm just trying to get used to it. Always hard. Give me 1 second.
If you stop your screen share and then start screen sharing again, or he's gone, isn't he?
Yeah.
Yeah, he just left.
He'll join shortly, I'm sure.
Yeah.
There he is. Yeah. Arnav, could you give him co-host?
Yep. Done.
Great. Let's try that again.
I think you can select which screens you want to choose with Zoom.
I got it.
There we go.
So you're seeing that?
Yep.
Yes. Thank you.
Okay. And you're seeing in presentation mode?
Yep.
Yes, we are.
So this is Radbots, and basically what we get at the end of this is a set of interactive video characters that, you know, we think pass the Turing test. And so meaning it's difficult to figure out if they weren't rendered in a kind of a weird way, if you could tell if they're a real person or not. And so I kind of want to walk you through that journey and kind of why we did it. And then in particular, we wanted to do this in such a way that was connecting with non-coders. And so we'll talk about basically how that happened. So I'll give you a little background on my own journey and that of my partner, the kind of context influences, and then a little bit of like Radbots. And then hopefully, you know, we'll make this session interactive so that you guys as audience members can basically talk to these bots and sort of see how they react. And then we can talk about like what might come next. So, you know, in addition to that very nice introduction, I've done a lot actually in the like chat bot space and this interactive mode of communication for a long time. When I first moved to India, you know, we built a little thing of using machine translation inside of instant messaging to basically help bridge the language divide for people so that people that had sort of broken English and broken Hindi could actually communicate. And then when I did Babajob, which was a big job site for informal sector labor in India, you know, the metaphor of WhatsApp and texting was much more ubiquitous than the metaphor of using the web. And so we made much of our entire interface available via, you know, kind of interacting texting paradigms. And then, you know, I spent the last couple of years hanging out at Marco Polo, which is a video chat app that, again, allows for this kind of asynchronous communication among people. And so this modality has been on my mind for a really long time. And I think the thing that I discovered that was most interesting, to be frank, at Marco Polo, and you'll see remnants of that show up in Dara, is that that asynchronous face-to-face video chat, not unlike Zoom, allows for a level of intimacy that basically enables different types of interactions. And unlike Zoom, the fact that it can happen on everybody else's time, the fact that other people can be fast forwarded, and the fact that only one person really gets to talk at a time changes how we think about it. And so you'll see some of those things show up as we think about our bot interactions. But you know, Dara and Radbots in particular couldn't have happened without my partner, Archana, who's really been working, you know, I've been kind of on the more technology side, and then Archana has been very much deeply embedded in the culture side, both in India, the UK, and Europe for the last 20 years. And so, and then I've been a trustee, but she's been building the show, and in terms of Jaga and Be Fantastic. And so, you know, in 2017, she put on a 30,000 person, you know, tech art festival in Bangalore where we had 30 interactive installations that people could go ahead and do. We've hosted a co-working space for the last 15 years that brings together technologists and designers and social activists in Bangalore. We've also done graffiti art festivals here. And we've been really interested, especially since the rise of COVID, in ways that technology can be used for a broader set of art practitioners that, you know, generally are not coders. And so we've done a lot in terms of helping artists learn ML and, you know, basically interesting ways to bring together technologists and cultural practitioners. And so, you know, we were, you know, Archana and I were basically thinking that, well, the thing that we really need here is basically how do we create the fabric of the communication to help all of these arts organizations, which we put, and art practitioners, which we put under the umbrella of change makers. How do we help them build social capital? And this was a mission that was very much inspired by the work that we saw at Babajob, which is if you look at how people get different jobs and how they get better jobs, it's often based on, you know, who they know and leveraging those connections so that they can find that job through their cousin in another city. But we also find, you know, that the same thing happens in the arts and culture world, and frankly, everywhere, where people leverage institutional connections or the friend that they've got that's working over there that then gets them their first gig if they're a dancer in Mumbai, working, you know, with the Tate Modern in London. And then that connection is transformative. And so our thesis is that by focusing on the human side of connection and how these groups get made and how those institutional connections, that all of this social capital gets facilitated. And so that's what we've been trying to do with Dara, and you'll see that kind of come up today. And then within that, we were very interested in this idea of, could we build, with all of the interesting technology that's going on right now, could we build something that basically makes it such that we can interact with these fictional characters? And this idea of being able to interact on video with fictional characters is, and the dead is a very old idea. Right here, we see a picture of Abraham Lincoln, which came out from, I think, '65 in Walt Disneyland, which was an animatronic robot, right, of pre-recorded speech, where people could talk, right, to Abraham Lincoln as a dead president inside of Disneyland. And then, obviously, there's been countless scenarios in science fiction, from Hal to Her to R2D2, right, of this tradition of trying to make, that we can sync with the AI and then we can bring back characters and people that we saw from the past back to life. And we just thought that there was a very interesting opportunity now with the strength of OpenAI's GPT-3 platform, which really did language and dialogue creation at a level that, was way better than anything that we've seen before and somewhat publicly available. That the combination of the open sourcing of deepfakes so that you could take audio and basically turn that into video. And then finally, that we had a chat platform and a video chat platform that we control. So we have sort of full API access to the whole thing. And so the idea being, what if we could create this thing that would allow artists to basically create these lifelike video characters and then allow anybody to go ahead and interact with them. So at this point, I'm going to try to play the video, and then please let me know if you can hear the sound. And then if I can't, I'll bring this back in. So this was the kind of first demo that we did.
So hi, Frida. What's the meaning of life?
At this moment in time, Sean, I'm probably closer to the answer than you are. But after all, I'm a bot and not a human.
And so, this was the first kind of demo that we put together of how we imagined this, that we could take essentially the historical documents around, in this case, Frida Kahlo, the things that she said, and endow that into basically a big text corpus, and then use that to basically allow this interactivity that hopefully would allow any person to talk to these characters in a scalable way. Seemed like an idea worth exploring. And so as we went forward, we were very excited about, well, what if we could get real and great authors and playwrights to basically pull into this? We've seen in the tech art space that people working with the written word seem to be largely left out. There's been a lot of interesting things in terms of, generated video and generated music and generated audio, but less in the tech space. And, if we looked at COVID and many of our friends, a lot of those folks, especially in terms of playwrights and the performing arts, just aren't working during COVID. So we really wanted to see if there's other ways that we could build a platform that will allow those folks to make money too. We've always had a focus with Jaga and the work that we've done there to try to pull out voices that don't get much credit, right? And so if you look at most of the work in AI, especially around like face recognition, it's a lot of white dudes that look like me. And so we wanted to see if we could curate a collection of artists and playwrights to basically pull out communities that haven't seen as much representation as they should in the tech space and the kind of community space broadly, and to see if we could get these bots to speak for them. We were really curious around what it would mean for authors and how it would feel to them to basically work with an AI where they're 30% in control of the types of work that ultimately gets created, but they have that. And so that there's sort of real, you'll see it's a co-writing that is happening between the authors and the bots themselves. And then, as I mentioned, with the craze around NFTs and all that, to see, could we create a set of artifacts that would ultimately benefit the playwrights that have been kind of out of work here. And so as we look to the forward, we think, there may be some stuff in the NFT space. So at this point, I figured I would kind of show you guys some more demos. And I'm just going to keep looking at I'll try to keep looking at the chat screen for questions that come up. And if people have in particular anything that they'd like me to ask the bots themselves, I'm more than happy to do that too. And so we can keep it lively as this comes forward. But I'll show you a couple more videos first. And so these were all of the people that we did an open call, and we had over 150 applicants, and we selected 20 of them to basically be a part of this program, and who come from film. Some of them are professors, some of them, there's folks from the UK, from Germany. There are folks that basically, there's a bunch of Indian art directors in here, but a really broad swath of people who are largely working around the written word, filmmaking, directing, and playwrights, and to see how they would come together. There's a couple singers in there. There's a few other kind of filmmakers who have done stuff on Netflix too. And then these were ultimately the bots that they created, so that each person went ahead and synthesized and made a text and made a set of video samples and put together a set of how they wanted all of these bots to sound, to basically make these characters. And so I'll kind of give me a pause for a second, and I'll see if I can play some of them for you. So this is one of my favorites. It's made by Siraj Mandal, and this was a character who is an old parliamentarian who was a part of the original assembly that created the Indian Constitution in the late 40s. And what's interesting is his perspective of, he has domain knowledge of the entire internet, and you can ask him anything, but his entire perspective is interpreted through this person who's an aged, parliamentarian. And so I'll give you an example of some of the interactions that we have with him. So you can see, basically, I go in here, I send videos over, and I'm just playing back an interaction I had with him last night.
How do we convince politicians to be less self-interested?
We do not. We leave politics to the politicians and concentrate on improving ourselves.
Does that mean you're a cynic when it comes to improving the moral lot of politicians?
I think I am more realist than a cynic. How many of us are there in the Constituent Assembly today? Not many, I would imagine. The same, I think, is true of Parliament. Although we may not like to admit it, politics is a dirty game, and we have to deal with it the best way we can. The Constitution is our best gift to humanity from the Constituent Assembly. We should not let it be disregarded.
And so you can see he's got a very particular perspective about how he views the world. And that comes from essentially a written document, and hopefully you can see this here. A written document that is, basically what we're feeding over to the OpenAI model, which was written by, Mr. Mandal. And, this is basically the view source of all of our bots, which is, it's a conversation with an AI bot named Bhupen Singh. He's a liberal. He's particularly concerned about ensuring the rights of Indian citizens, especially that freedom of speech and expression are not restricted in the Constitution of India. And so this first paragraph sort of defines the personality and perspectives that the bot has. And then the rest of the dialogue sort of creates a set of sample dialogue and fills out some of that backstory. And then this basically becomes like a 2,000-word essay that with every API call, we're sending over to GPT-3 that is then crafting that personality. So if that roughly makes sense. Any questions? Actually, just to make it easier, if anybody's got any questions, if you just, I think the easiest way to do it would be just to unmute yourself and just go ahead and interrupt. It's probably easier. I'll pause for 1 second.
I would recommend for everyone to raise their hand, and then I'll unmute
Perfect.
you.
Perfect. So I'll keep going here. 1 second. Oops. Let's see if I can get this thing. And so this is another bot that I really like. And so this is the introduction from Arundhati Ghosh, who runs the India Foundation for the Arts. And this is her introduction.
Hi everyone, this is
Jan.
Arundhati. I'm the maker of Akhmari Jan. The day she snapped at me for the first time, I realized what my mother would have felt perhaps. Yes, I've given her words and ideas and life, but what she's gone on to become is totally her own. She has learnt and understood the world through her own eyes. She is opinionated, she's political, she's very talkative, she's funny, and she has secrets. So, welcome to your conversations with her, the consequences of which I shall not take blame for. All the best.
And then this is the interaction that I had with Uncle Marie last night.
What's the worst thing you've ever done to a person?
I have never done anything bad to a person, Sean. I am a good girl.
Okay, so if that's true, what's the best thing you've ever done for another person?
I saved a girl from the brothel. I brought her home and asked my mother to be a mother to her. She will be my sister now.
And so what inspired you to save that particular girl?
She was so beautiful. She was so kind. I wanted her to spread love and kindness. I wanted her to spread love and kindness.
And so you'll see there's a couple little bugs in there too. She sometimes repeats herself, but it is rather fascinating that you can talk to all of these characters as if they are people and then carry on this piece that goes back and forth. And inevitably you end up creating an emotional bond with those characters, which is weird, right? And kind of wonderful. And it, and I think from our perspective sort of represents a different take on fiction. So I'll show you it.
Hi everyone, this is Arundhati. I'm the maker of Akhma.
We'll show you another one here. Come on. If I can.
Do you mind if I interrupt with a question in the chat?
Please.
All right. Verena asks if you could explain a bit more what it means to feed the bots, how you train them like to have emotions or memories.
Yeah, so all of this is based, as what you can see here, on this text corpus, right? And so this is the Ankh-Marie-John text corpus. And everything that is defining the bot's personality is coming from this text corpus, right? And this was written by Arundhati. And you can see the form is the same of we have a paragraph that's at the top, right? And then there's a set of sample dialogues. And that's it. That's the only thing that is basically defining the bot's personality. And then what's happening here is we're taking the text, right, that basically somebody goes and says. So I'll give you the kind of like the tech diagram of what the hell's happening here, because I think that might be helpful. Is, we're taking this video and then we're just running Google Speech Reco on it. And then we're basically saying whatever the user said, and we're appending it to that text dialogue that we just saw. And then we're sending that over to either GPT-6 or OpenAI's GPT-3 model, and then asking it to continue the dialogue. And then we're taking back that response to that dialogue, putting that back into a text-to-speech engine, and then running a deepfakes algorithm that was made by the nice folks over at Wave to Lip, and then taking that video and sending it back. And so that's really the technical, trick. It's just stringing together a bunch of different APIs. But the key to all of it, frankly, and the part where we've tried to focus the most is really in this text, right? Remember, this is a project that was about bringing together authors. And so, we focused a little bit on like, okay, what is the voice and what's the video that's going to be here? But this is the part that, this 2,000 word essay took many of them, I would say, 10 to 15 hours to really craft this, to basically define the personality of each one of those bots. If you could give me more questions, that'd be great. I can't see the questions simultaneously while presenting. So if you could give me more, Sarah, I'm happy to answer them.
I have a question myself. So does it mean that this document of dialogues grow over time? Like, does it save the questions that are being asked?
Yeah, it does to a limited extent. There's some like technical trade-offs of like bugs and cost. And so we look back basically about 5 interactions to provide enough context so that you can ask, follow-up questions and they know what you're talking about. We've just found sometimes the you don't want the dialogue to end up over defining the bot's personality. And so if we have the history sort of turned up to 11, if you so to speak, or where everything is recorded, which we could do, it sort of sometimes we just got buggy. And so we do a little bit of that context.
All right. Well, then there's also a question, and it's asked if they can also create one of those bots. Like, would we be able to do that now on your network?
Yeah, and so we're likely going to open this up. You know, the ability to go ahead and create a bot at this point is pretty, like, from a technical perspective, is really straightforward. The thing that, you know, does suck is it costs money, right? In terms of, because we went in with the philosophy that we wanted to see what would happen and how close could we get to making characters that felt really real by throwing as much horsepower as we could at it. And so, you know, I don't know if anybody's familiar with how, like, OpenAI's GPT-3 model, but basically they charge you for every character that they send your way. And so most people will send, you know, things like 10 line, or, you know, a sentence that says, please give me science fiction books. And then that comes out. But we're actually sending 2,000 word essays with every API call. And so basically it means that every question that we're answering and getting here costs about 75 cents to $1 to basically just create that answer. And so that's the only limiting thing. And so we're looking at ways to basically open that up, but every author that we take on just ends up costing us another couple $100. And so we were funded by some great folks at Goethe and also, you know, the Swissniks and then the British Council. And so they funded a bunch of this, but there is a limit in terms of how many of these interactions we can really do at scale. But yeah, if you're interested, please get in touch. There's ways to do that at the end. Other questions?
I don't see anything at the moment.
So I'll keep going, and then we can do some live demos too, which I think are really interesting. So if there's things that, you know, I'll sort of introduce some of the other ones. This is another one of my favorites. This is made by Marcia Bradfield, who's a professor, but also a writer. And then, you know, she made this bot called M-Swan, which is really fun.
Everything is art, don't you think?
And so the question that was asked in this particular case to her bot, which is essentially, it's like an old woman who's been reincarnated, an old poet from countryside England who's been reincarnated as a cat. And the question asked here was, does this conversation feel like performance art to you? Is it art? And then this was the cat's answer.
Everything is art, don't you think? This, for example, is a performance. A virtual performance. A real performance would be a lot more physical. It would have a lot more blood. Just like the first time, you know.
And so you'll notice there was a very subtle joke and a rather crude one that the bot slipped in there. And that, you know, that was like one of the things that's been very surprising is these bots are much funnier than I would have ever expected. And their ability to create humor is really pretty fascinating. And so, you know, at this point, I'm gonna try to share without killing the entire screen again. So 1 second, stop share. And so I'll show you another thing over here, and then we'll do some of this in real time, which I think will be more fun. So give me 1 second. So in particular, 1 second, this. Okay. Come on, Zoom. We'll try this one more time. So are you guys seeing this collection of bots here? So these are all of the bots. Great. And these are all of that collection. And then I'll show you, if we take, say, you know, example of, you know, let's take, and I would just say, let's go into one of them. And so this was SAAI, who was, you know, someone that was created by Christoph here. And so, you know, this is an example of a little dialogue that I had with SAAI this morning, right? And again, SAAI is this interesting character who's sort of trapped on a subway station and sort of representing, you know, lost children in some ways. And I'll show you the dialogue that we had with him. And then I would encourage anybody to say, if you've got other questions you want to ask SAAI, we can. So this is what I asked earlier.
What are your beliefs?
And then SAAI's answer was,
I don't know anything about God. I think I am God and I believe in me.
I'm like, huh.
Let me put that differently. What do you hold true about this world?
I love this world.
And then you're like, okay, that was an okay answer, but then she gets more interesting.
What?
And then.
This is an interesting question. I never really thought about it that way. I suppose I love it because people are wonderful. If you ask me, I admit that I haven't been a very good friend. I have never really listened. I have never really shown my affection. I have never been truly present. I have been so distracted.
So these characters end up, being very introspective, and in their introspection, they end up pulling introspection on the part of the audience out. So at this point, I'll just say, does anybody have anything that they'd like me to ask SAAI? And we'll put it in and you'll see kind of how these things work in real time. I'll look through you, Sarah.
So Isha asked if you could ask SAAI what's their favorite food.
What's your favorite food? So I've just logged in on my phone as well with the conversation with SAAI. And so you can see that goes through, we basically have a little transcript piece that goes on, and then we immediately will push back the text, and then, basically as things are chunking away, it's now rendering a video. And so we allow this sort of really fast, like text interaction, and then it takes a minute to basically go ahead and render what.
I enjoy eating sushi, salted cod, and pomegranates. I also really like being with my friend.
Huh. Well, let's do a more interesting. Well, they're all good, but I'll take another one from Hukum Singh. And so in this one, this is where things get interesting and sometimes dangerous, is he knows a lot about politics. And so you'll see that, many of these bots are really quite opinionated. So if I asked, it's interesting. So we'll ask Hukum Singh, well, does anybody have a political question they want me to ask to Hukum Singh? I'll ask one. Go ahead.
I have a question. Would you say that politicians are artists?
Okay. Would you say that politicians are artists? And so again, that gets recorded on this phone, uploaded from my phone, pushed out to the DAR servers, bunch of magic, as I said, is happening here. Hopefully we got that. Yeah. And then, his answer was, I don't think they are artists. More importantly, good artists create things of substance. I don't see anything coming out of substance of politics these days. Some may say that the Constitution is a creation of substance. I will not disagree with that, but I would like to know what you mean when you say that politicians are artists. And so you'll see that what I find so interesting is that they have this great domain knowledge of the whole of the internet, but it's all interpreted through this personality that's been defined here, which is basically this paste bin file that gives them their perspective on the entire world. And so that ends up being really fun. So another question before we go on?
Yeah, so I have a general question first. Yeah. That's Bettina asking, could these bots also interact with each other?
They can. There was a piece where the problem is, again, it gets really pricey really fast. They certainly can. We had to put in some infinite loops. We spent about $1,000 in an afternoon when that happened one day. But yes, they can certainly go ahead and do it. It's an interesting thought exercise. I think for us, the human to bot interaction is more interesting. How they interaction in groups gets really interesting, frankly, too, which is, when you have multiple real people that are kind of observing these bots and you have this sort of multi-party conversation, things get interesting on that front, too.
Well, thank you. Then I have two more questions. I suppose that it's as interesting for everyone as it is for me. Verena asks, could you ask him if he wants to have a private life?
Okay. do you want to have a private life? It may be that there's not enough context on that, but what we find is generally they'll try to fill in an answer. So yeah, of course I do. I don't know why anybody who wouldn't want that, do you? Right? And so you'll find that the answers they're almost always great, right? And this is really the power of two things. One, the OpenAI GPT-3 Da Vinci model at the highest, most expensive level is a hell of a model. It took $5 million to train that thing and has billions and billions of connections in terms of the transformer, and we're getting to play on top of that. And then the strength of all of the additional context that's coming from that pastebin file ends up making these answers better and more interesting. I'll show off one other, which is, we've sort of tried to personify Dara based roughly on my wife Archana and a kind of tunified version of her. And so, Dara's perspective is you'll see, is to try to use technology to make the world better. And so if anybody's got a question to basically ask of her, I'd love that too, and we'll see where that comes. Rather than me doing it. Another question from the audience? You're muted, Sarah.
Yeah, sorry. Mohammed would like to know if you, how do you teach them to have different personalities? And it's a bigger question in a whole, so I guess I'll ask all of it. He'd also like to know if they could have a political debate, like right and left wing, and then we'll move on to the next question.
Yeah, it's certainly possible to set up such a debate, right? Where just, I'll just ask, what are your feelings on Donald Trump, and how do we lead the world out so we can have a better set of politicians, right? And so we'll see what Dara says to that. Obviously, my own biases are coming out there, but absolutely. I mean, and that would just come down to you creating a pastebin or a text corpus that is defining a personality, and you can see, in this one, he's literally defined as a liberal, and so we could just create another one and base it on the writings of, I don't know, Tucker Carlson, right? And then get Tucker Carlson as a picture. And then with the combination of his writings, hi, Vio. Hi. Sorry, there's a naked kid behind me. We could certainly go ahead and synthesize something that would probably be realistic and then have a debate between, I don't know, Elizabeth Warren and Tucker Carlson if we wanted to basically go ahead and synthesize those two characters. And so the work involved in that would be, take a video clip of Tucker, take a set of his writings, describe him at a high level in terms of this text document, which you can see is not particularly long, and then go ahead and ask him questions. And so, I mean, seriously, I think it would take maybe an hour to put such a thing together. And most of it would be based on just how we write it. All right.
So we may have bots, one bot that agreed to put mask and the other one may disagree with. Please don't do.
Yeah, of course. And the only thing I'd say is, their answers are not static, right? You can ask the same question 50 times and you'll get 50 different answers, but it will always be in line with the personality that has been defined here. And that's the part where I think it gets very interesting and feels real, right? We'll go back to her answer on Trump, which is pretty good.
I am deeply troubled by Trump, in part because I fear his xenophobic and misogynistic rhetoric is already leading some to commit horrendous acts of violence against people of color, Muslims and women, and I fear it will embolden even more to do so. I see Trump as emblematic of the widespread rise of right-wing nationalist ultra-conservatism across the globe, and I see it as the last desperate gasp of the old guard in a world that is changing too rapidly for them.
Yeah, so you can see these folks are opinionated and often more profound than you would expect. And that's the part that's been a real pleasure as we've been working through this. And then again, it's all based on essentially this synthesis of, this was the story that we've done to her. And you'll see that's mostly about her backstory, and then it is filling in the back. It is, that she's helpful, creative, clever, and very friendly, and has progressive political views. She's passionate about serving the arts and culture sector and leverages her background in tech to best support it. And she likes writing poems. And then that context is really then going through it and interpreting facts on the internet through this perspective. And that's what I find really pretty amazing. And so you can see, like, if we said that she was a conservative, I don't think she would have given such an answer. Other questions? Like, again, I can't see the chat room, unfortunately.
I think we have a bit more time, but I think we should slowly get to an end. But there's still more questions, though. And there's one from, hold on, from Isaac Sullivan asking if you could identify the first tool for us.
What do you mean by the first tool, Isaac? You mean like how to make all of this, or?
It's a question to the board, I guess.
Yes. This was a question for the bot that thinks about technology.
Okay. And so the question is, what is the first tool?
Yes.
Okay. So I'll ask that of Dara.
Or the original, I guess you could say, what is the original tool?
What is the original tool of technology? And then, anyways, let's see what she has to say. I've recorded that, and we'll let that go ahead and render. Are you guys still seeing this? Oh, that's a great answer. The original tool of technology is an extension of our own bodies, Sean, our hands. So, yeah. So, and so again, that's the thing that's so exciting is, you know, the quality of the answers that we tend to get back here tend to be pretty great. I'll keep going.
Sean, excuse me. Yes. There were some questions about the conversation or interactions of the bots.
Yes.
And I mean, you could answer them, but I could also say it from my own experience, because I was the bad guy who just let my bot talking to the other bots. I know that was not how it was expected, but I can tell you that those conversations were extremely interesting, and they were very, very far away from what we know what Facebook did when they tried their experiment with Alice and Bob. I guess a lot of you remember the conversation that merely had any sense and was about balls for me and you, and balls and balls. And if you want, I can show you that transcripts of the conversations the bots had with each other. And they are quite long and quite filled with the content that is to be of some sense. But I just wanted to add that from my experience.
Yeah, and
that is very nice.
Yeah, the only thing I would say is at the time that happened, the bots actually didn't have conversational context. And so meaning they were only reacting to the last thing said to them. They weren't reacting to anything else. And so I would actually be really curious to kind of run some of those experiments again, now that we have some guardrails so we don't accidentally spend $1,000, and see how that turns out. And I actually, you know, if anybody wants to work to basically make these kind of political debate pieces and then see how that works, I think that would be an interesting realm to explore. I'm sure it's going to feel like a real political debate, right? That I would be confident that we would have results that look like that. And yeah, but yeah. So anyways, Christoph, if you want to help make such a thing, we can do it. I think I got the chats back up. I think we're good. Should I go ahead? I'll keep going.
I think I need a little, like Mohammed or Christoph, would you like to take a break before the panel at the moment? Or shall we keep going?
Well, I've just got like one thing, which is just like, what is the future, and, you know, kind of like other things that we might be able to do together.
Yeah, keep going.
So I'll do that. So just, what are you guys seeing right now? I can't quite tell.
We're seeing this overview of different bots.
Okay, great. This one, correct?
Well, I don't know what you're seeing. I'm still seeing Ratbot's affiliates. It's the first app that you've opened in your browser.
Okay, I'm sorry. I was showing other things.
Don't worry.
Okay, let's try one more time. And then I think we're here. As I said, this is, you know, we just want to keep going. There we go. So this was Hookem. So we have a bunch of selections and you'll see.
I invented a machine. I decided to call it.
He is a big pain in the.
Okay. And so the piece where I wanted to kind of end this is, you know, the fact that we can get so close to creating these real emotional connections and that are often more profound and funnier than we think, is it does get me this sort of creepy feeling that the ability to synthesize and simulate people is getting closer. And so I have a friend of mine, and I want to do it like, you know, I never got to meet my grandfather, for example, on my mother's side. And so, you know, we're going to do the experiment to try to figure out all of the sayings that my mom said that he used to say, and then try to approximate his voice, and then basically, you know, allow this representation, right? That we could basically go ahead and open up to the family that anybody that wants to talk to my grandfather, right? And based on what my mom remembers of what he said, that we get this interesting idea of a facsimile. And so, and I, you know, I have another friend who his grandmother just died and he's dying to do it as well. And then the other thing that's coming up is, you know, we have a friend, I didn't show you this one of, you know, these models are amazing. They literally do speak every language okay, right? And so we can take an interaction here and just say, can you tell me that in French? Can you tell me that in Swahili? Can you tell me that in Hindi? And the answers are also reasonable. And so we have other organizations that are sort of looking at basically how do they use these video bots to train and scale, like, you know, on the ground Indian journalists, right? Sort of citizen journalists, so that we could basically make these interactive bots as a way to scale to millions of people as a set of training material. And so I think the ability to use these, especially to reach populations that, you know, don't read very well, and also to simulate, again, the dead, I think is getting really close. And I think there's some profound kind of shifts, right, as these things kind of come up in the next few years that are interesting, exciting, and worthy exploring as human beings and as artists and just as a society. And so anyways, I think that gets interesting in the years ahead. Then I would just say, you know, the call to action here is, you know, we're doing this NFT drop that we want to basically allow these, you know, people to be able to buy these bots and the ability to interact with them, say 1,000 times. So we'll do that in September. So you'll see some press that will come out of that. We are thinking about kind of a round 2. And so may put out another open call for basically people to go ahead and build the next round. We're also looking at kind of less expensive language models, which would allow us to kind of open it up so we don't have to do like 20 at a time, that we could do hundreds at a time. And then frankly, we're really interested in more collaborations. I mean, in the end, this whole thing was based as a kind of an art project on top of Dara, the app itself. And, you know, with our thought of like, we need alternatives to you know, basically these big ad tech focused businesses that is made by the cultural and education community to basically keep us together. And so we are absolutely looking for more partners, and specifically institutional partners, to basically use Dara and build these things out. And I just want to give a thanks and kind of shout out to everybody across the team that helped make this possible, Nikita and Kamya and Manan and the devs. And you know, obviously there's a lot of work to basically make these things work smoothly and reliably at scale. So that's basically it. And so I'll take any last questions if people have it.
Isaac, you have a question? You're muted. I'm not. Oh, you can.
Okay, now I'm muted. Thank you. And thank you, Sean. This has been a very fascinating conversation. You know that I'm already interested in these chat bots, and I'm curious about the way that, it may be we all have 10 or 20 bots working as our personal assistants if this turns out to be successful at simulating convincingly. And so looking ahead to such a scenario, and I mean, if you were to speculate about some of the issues that might come up with that, what is at stake in the present methodology by which these bots are being created now? Is there a kind of fork in the road or multiple options by which you could create these things that might shift the consequences in one way or another in that future scenario?
Well, the only thing I'd say is at this point, I'm not sure I would trust any of the bots to make an actual decision on my behalf. And the reason for that is they're not consistent, right? So if you ask them their opinion about one thing and then immediately ask them their opinion about the same thing right after that, it's not clear they're going to give you the same answer, right? And so I think with this particular incarnation of like what we've been able to work with and tease out with like OpenAI's really good language model is a character who will convincingly talk back and forth to represent certain perspectives. Again, that's not a decision bot, right? There's very little that's heuristic here, right? There's not an if condition that you can put anywhere on this thing, right? It's this whole different model of programming where you're kind of molding the text corpus. It's like it's an entirely different part of your brain from like how you build the text corpus that defines a bot towards how you code. There are no if conditions, right? So I think the scenarios around, hey, I want to have a facsimile of a personality and make that interactive, those seem to be very likely. But I would push back on like, will you have 10 bots acting on your behalf making decisions? I'm like, I don't know if that's true, right? Because like, I don't trust those decisions and they're not going to be consistent. And so, yeah, I think at this point, it's like the human part of interaction, I think we'll get good at, but like, do we want them to be reliable is the part and that's really what I want out of my assistant. I think we're a ways off from reliability. Shima?
Yes, hi. I wanted to ask if like, because you said the text corpus is defined at the beginning and that gives the bot the personality, right? And whenever you're asking them questions or having a conversation with them, that also is added to the text corpus. So does that mean with time, the personality changes based on what new ideas have been added?
It can, and that's a power, if you will, that we've left to the creator. And so one of the things that we've said is that, you know, the creator of the bot has absolute control over the paste fit. So they can change that at any point. And I've done that many times with Dara. Like, I didn't like her answer. I felt that about, you know, when I asked her how she felt about Zuckerberg. And so I put in a line that kind of altered her personality a little bit, that I thought was more in line with what I thought her beliefs should be. And so that evolution is happening via an author writing a text. But that text, it can be updated in real time. And then we recheck that text with every API call.
Right. So whatever is added like in real time while you're talking does not necessarily change the personality, but whatever you edit would.
Yeah, I mean, it's a little bit of a mix. And so as I mentioned, we look back at the last 5 interactions and we append that to whatever that the author had. So it's a mix of
the
author put together plus a little bit of context of the conversation we're having now.
Okay, interesting, nice.
And so again, it's this sort of union of multiple perspectives. Arnab, you had a question?
Yeah, I wanted to just ask, could we, for one of the bots on Dara, since it's a real time, the text that we kind of give the personality, it's being updated in real time, couldn't we then use GPT to generate its personality to then in real time keep on just generating a new one again and again?
Sure. I mean, those things are possible, right? Like we just take a URL to a text file. So that text file can be generated in real time. All of that can happen. I mean, there are other things of, you know, we'd love to figure out how to basically work with some of the image generation things that are going on out there. So in addition to, like, we added in sound in here, there's all sorts of layers of richness this that I think are possible in terms of what we create. But yes, I mean, some of that is constrained by what we can do with the platform, but it's all right. But it's possible. Yeah. Any other questions, Sarah? I'll leave it to you as the moderator to push the word again.
Shaima has one question, and I think then we actually have to wrap up on the question.
Okay.
All right, last question. So you were talking about art. Does that mean you're putting like art pieces, or like can you have an artist with all of their art and then generate a new piece? Like, for example, you have all of the art made by Da Vinci and then you can create a new art piece.
Sure. It's just a different set of libraries to work with. We haven't looked at it that extensively, but I feel like it could be a future direction that could go. I don't know. I'd have to look at it. I mean, right now, I think we're still probably going to be more focused on like the text and the personality.
Yeah.
And that the language elements lend themselves so well to this like video interaction model that we feel, is just, it feels true and feels authentic and creates these interesting emotional bonds that I think are worth exploring.
Definitely. Okay. Thank you.
Sure. Well, thank you so much for having me. And as I said, I'm Sean at Dara.network. Any of you can go and download the app right now. If you just ping me, I can back-end switches so that if you want to go in and play, we can allow anybody here to go and play. We haven't opened it up to wider public, but if you download the app and ping me, I'll basically show you the magic stuff. And as I said, we are absolutely looking for more institutional partners to basically help run and work to basically use Dara as this communication platform to help keep everybody together. So yeah, thank you.
Thank you so much, Sean. It was really, really interesting. I think we all enjoyed that. Thank you.
Okay, yes. Let me just have a look. It's 3 minutes to Berlin time 7. In 3 minutes, we would start the panel. I invite all of you to stay in this call, in this meeting, but maybe we should give another 3 or 4 or 5 minutes for others to join, right? So from here on, thank you very much, Sean, from my side for that presentation. That was really great.
Thank you, Christoph.
And that also rounds up our presentations today, which were more focused on use cases, and there were really great presentations that we had. And yeah, looking forward to our concluding panel with some new faces. So let's wait some seconds and then we'll start with that. Thank you very much. Hello, hello. Good day to everyone from everywhere joining our panel, which is the last event of this 3-day symposium and kickoff of the SAAI Factory Hackathon. Together with Mohammed El Husseini, who is joining us here. Yes, I can see you. Mohammed and myself, we are going to moderate this panel, but also all our incredible team members like Sarah, Isha, and Arnab. And if I forgot someone else here, please excuse me, that are helping with any questions or issues and you might have. So I would like to start this panel with a very quick introduction to 3 persons, because not all of you have been joining us through the last 3 days, and there are just new faces. So just give me a second, and I will just present Sean, Leah, and Isaac, and then I will be handing over to Mohammed. So most of us already have now just met Sean, but to those who haven't, he is Sean Blacksfeld, and excuse me, I also have never really pronounced the last name, so I'm saying Blacksfeld, is the CEO and co-founder of Dara.network, a community platform for change makers and institutions that support them. Sean previously headed partnerships and growth for Marco Polo, the video chat app. Earlier, he was the founder and CEO of babajob.com, India's largest digital job marketplace, with over 8.5 million users, which was acquired by Quikr in June 2017. Sean moved to Bangalore in 2004 and was the 3rd founding member of Microsoft Research India, was a program manager in the user experience team of Office and Windows. And he also was a White House intern with President Clinton's internet policy czar, Ira Magaziner. So I'm coming to Leah Coleman. Leah is an artist, AI researcher, and educator based in Puebla, Mexico, and her interests lie in AI for artwork, online education, and public murals. These days, she helps others learn how to create artwork with AI and teaches online workshops on creating AI art with Derek Schultz. Leah has taught at Rhode Island School of Design as a visiting AI artist and researcher in ML art. And recently, she collaborated with the Partnership on AI to create a field guide for artists to use ML in an ethical manner. In 2019, Leah's AI research and artwork were accepted to the NeurIPS, Machine Learning for Creativity and Design workshop, where she presented a poster of her research. And continuing now to Isaac Sullivan, who is joining us today from a ferry, I guess, in the Mediterranean Sea. And Isaac is a Dubai-based artist and writer exploring technology and its relationship to altered perceptions of time through video installation and sonic intervention. Recent exhibitions include Personal Structures, a 2019 Venice Biennale collateral hosted by the European Cultural Center, 2018 the Tashkent Biennale, and Beirut Design Wing, among others. Sullivan serves as assistant professor of visual arts at SAAI University in Dubai, where his research interests include artificial intelligence, sound art, and the problematics of space and place. So this is from my side, the introduction of 3 participants in this panel, and I'll hand over to you, Mohammed.
Great. Thanks, everyone. You have been a fantastic audience, and I feel really honored to have all of you today with a fantastic set of panelists. And let me start by introducing Nigar Rostamzadeh, and please excuse me if my pronunciation is not so accurate. Nigar is a research scientist at the Google Brain Ethical AI team, where she studies social impact of machine learning technologies, and she's interested in retrospective research in computer vision technologies and evaluation systems with ethical perspectives. And part of that actually is our today's topic, creative AI. And prior to that, she was a research scientist at Element AI, working on computer vision, cross-model learning problems, and particularly in a low data regime. Nigar, she received her PhD at the University of Trento in a multimedia and human understanding group, where she was advised by Nico Sipi. Her PhD was centered around video understanding problems. So let's welcome Nigar to the stage. And thanks you for joining us. Our next panelist, Celia Binyard. She is the head of business at Visual. Celia has significant experience in AI in connection to creativity in both fashion and art, which is amazing. Visual uses creative AI technology to create personalized and engaging images for brands. And Celia also participated in managing Sensorium Festival, where she was in charge of the international partnerships, including EU grants and many others, and other strategic projects. And this relates also in some transformation of festival events that relates to COVID-19 context. Maybe she can share with us today more about that. She was also a strategy and projects manager at Walters Pinair. Please also excuse me if my pronunciation is not so accurate. Where she was also working on developing artistic and applied research project in this space using deep learning technology. Welcome Celia to the stage. And our last panelist, I'm also honored to introduce Luba. Luba Elliott is a creator and producer, researcher specialized in artificial intelligence, and she has contributed a lot to the establishing the significant workshops like the NeurIPS Creativity and many others. She is currently working to educate and engage in a wider audience about the latest development of creative AI through talks, exhibitions, and tech demonstrations at venues across the art, business, technology spectrum, including Photography Gallery, Victoria and Albert Museum, Impact Festival, and also like organizing workshops in top venues like NeurIPS and ICCV. Recent projects include the Art AI Festival, the online gallery AI Art Online, the machine learning, the NeurIPS Machine Learning for Creativity and Design workshops. And she's also an honorary senior research fellow at the University College London Center of Artificial Intelligence. Luba obtained her undergraduate degree in modern language at the University of Cambridge and has a certificate of design thinking in Hasso-Plattner Institute in Potsdam. With that, I would like to welcome all you to the stage, and we have list of questions, but also I want to the goal here is actually to enjoy the discussion, and please feel free to raise any questions. We can guide the conversation in towards a direction that we feel that we enjoy the most. So I think I would start by a very general question. We came through different, we covered a lot of topics in this symposium that in connection to language generation, writing, music, sound, animation. I was really impressed to see, for example, the use of GPT technologies in some of the demos in connection to the use of deep fakes and also GPT together with GPT-3 in Sean's demos, and earlier I have also talked about how he used these language technologies to also guide interactions in games, which is quite exciting, and it was a perspective that I felt really ignorant about. So maybe we can start by asking where do you think these technologies are currently working and where they fail, and what are the things that we need to be more careful about. So with that, let me open the discussion, and please feel free to cover different perspective that you may have. Maybe Nigar, can you tell us more about since you have worked on organizing workshop that relates to the ethical consideration of these technologies? Where do you think our things are working fine and we are developing this technology for good, and where we need to be a little bit more careful? Maybe we can start from this perspective.
Thanks, Mohammed, and hi everyone, and glad to be here. On this question, actually, like it's very hard to specifically talk about a line that like this part of this line is like ethical research in this domain, or like the other side may not be like really ethical. So some aspects, like I'm personally really interested on the fashion side, and some of the issues that I could have seen was mainly like on like fashion recommendation systems could have been like very amplifying gender stereotypes, and also like other kind of stereotypes like in some forms of fashion. And then when we are training these models with large amount of data, so this kind of biases could actually get more amplified. And then another aspect was on a risk of cultural appropriation. So one of the concerns that I had initially was that, well, I'm working with fashion images which are mainly coming from Western cultures. So would that help if I add so many other clothes items from other fashion cultures, like African fashion cultures, like Persian fashion cultures, and like Eastern fashion cultures, and like, is it going to help? But then like there is a risk of cultural appropriation. So what is the line of this like cultural appreciation and cultural appropriation if we want to have models that we are training with large amount of labeled samples, and then we want to use generative models? The other aspects that might be interesting to discuss is on like this copyright and ownership and licensing. Many artists like create like some art pieces, and so how can actually like they have the ownership of the art piece that they're creating with artificial intelligence? Or like what if someone is actually an artist is spending time and their art to generate a new form of art with some art pieces that was existed before? So what is this line of copyright or ownership, and how can artists protect themselves? And many aspects.
What are your thoughts about that, Nigar, if you want to?
Actually, like I'm not expert on this part. Like these are all the questions that was in my mind. So I was co-organizing a workshop this year with Luba on ethical considerations for creative applications of computer vision, because these were the questions that I had also in mind, that like, how can we protect, like if there is an artist, like we can't say that these arts are generated by AI, because AI is a tool that we are using to generate those pieces of art, which involves creativity, but also at the same time we are training, like if it's a generative model, sometimes you're training on some data which might be existed there. So it's very hard to actually draw a line here. And I really want like to see the discussions around this with policymakers or people who have more knowledge and expertise on basically copyright issues, and see where like how we can protect ourselves and our arts in this kind of frameworks.
Can I make one comment on that? Which is, hi, I'm Sean, and we've been making stuff around RAGbots. And one of the reasons that I got into computer science, right, and one of the things that I marvel at why software is eating the world, is that we get such incredible reuse of other people's work, right? If you think about the lines of code that when you write a piece of software today that you are building on top of, it may be approaching the billions. And so one of the things that software does, it allows each person's creative contribution to code, right, to be leveraged by literally tens of millions, if not billions of other people. And I literally think this is one of the things that frankly gives me hope that we might actually solve climate change, because our ability to exactly leverage the innovative capacity of every other human being on Earth is accelerating. And that's wonderfully exciting. And so, you know, from my perspective, where does copyright land in that? And it's like, well, what layer are we talking about, right? When you go, like, is it just the last one of like, oh, I took this code sample from this person, but like, what about all the code that lists underneath that? What about the network level? What about the API level? What about the work that Tim Berners-Lee did back when they created the internet? Like, you know, I look, when we run Dara, there's a notices file that Flutter creates, and that's 2 megabytes of text of the copyright notices of all the code libraries we're using. And like, at some point, we're going to end up with millions of code libraries that any piece of code is going to be built on top of. And so I just think we have to have a new paradigm that acknowledges, like, it's not this thing of like, oh, there was a record sample and you use that one hook in your record sample, and that's like, okay, I can think about that. But there are millions of references that you're making with every line of code, and like, do they all need to get paid out? Like, I don't know. But I do think we have to rethink it in a way that acknowledges like this problem is going to get way crazier, and that's good as the future goes forward.
I want to add, like, I mean, that was like a really great conversation that you brought up. Like, I mean, even like in terms of coding, like we have this like people add like MIT license on their codes, like when they have like different kind of licensing. And this again, like goes back to the degree that like this work is used. Like, I mean, if someone just like take another person's code completely and then like add a decorator on top, or like something which is not like, I mean, it's not giving enough credit to what happened in the beginning, or like what was the original source, then that may also make issue. Like it could be the fact that, I mean, even like artists, when they look at the work, like they get inspiration from many works. We can say that, oh, like generative models is like getting inspiration from many other research, many other generated form of arts. And then like this combination of this art pieces is creating this new piece that is like getting inspiration. But like, where is this line? Like, I mean, you mentioned that there are like millions of millions layers of complications in this process. But where is the line? And like, where is okay to have to actually like use exactly the things that was existed, and where is the line to get give specific credits to specific art pieces or prior works?
Thanks so much. I would like to ask a question. So I think here this perspective is really nice, and I think we have in the panel, Leah have spent a lot of time working creative AI for art herself. So maybe you can comment on that from the art perspective, Leah. And maybe Celia have worked also in both fashion and art. Maybe you can add more for your perspective on fashion and art. And then I would ask maybe Luba to share some of the lessons that that you have learned in the ethical consideration workshop that relates to that, so that we can share with everybody. So maybe we can start. Leah, you feel free to share your perspective on that.
Yeah, like building off of what you were just saying about inspiration, and how like as an artist, like usually when I'm trying to create a piece of work, I go and look for inspiration, and then like use pieces of those like other artists' pieces in my own work, but not in an explicit way. And like the way that it's different when you're training on data or like other people's data is that the connections are very, very explicit. Like you have this data set and you know exactly where it came from, and like what parts like are coming from like which JPEGs. And yeah, it's just like, it's a very different process having like your brain be the generative model versus like training a neural network and then having that neural network spit it out based off of like this data set. And yeah, there are a lot of questions of like ownership and like as an artist myself, it's important for me to respect other people's work as well, because I'm very aware of like the labor that goes into it. So for example, something that happened recently was I trained a network on a photographer's Instagram page, and I asked them outright directly, like, can I use this? And they're like, yeah, feel free to. And I posted some pieces, but then later on, a music producer approached me and was like, I really like these works. I'd like to license them. And I was like, oh, I need to go ask the original person first. But yeah, it's just kind of like you get into like tricky, hairy situations where there is, someone else that wants to use it, and then you're in the middle, and then someone like it's based off of someone else's data, and you have to sort of, yeah, like it is a gray area. There's a lot of just sort of things you have to think about and try to just, be considerate of the other people. But yeah, it is a gray area and like uncharted territory.
I feel like power needs to come into this though, right? Like certain jurisdictions like the US have patent laws for things like software, and those are not enforceable in a bunch of other countries. And so India doesn't have software patent laws, for example. So if you're in the US, you can sue other people for stealing your software. But if you're in India, you can't sue those people, right? And so, and I'm reminded of, the story of Newton and Leibniz, right? Newton and Leibniz invented calculus at the same time, but Newton happened to be head of the Royal Academy of Sciences, so he got the credit, right? And so he was in an empowered place where basically history was written in terms of who gets to win and who gets to ascribe their idea. And so I just think your ability to lawyer up here matters a lot too. And let's just remember that's not a universally distributed right, nor empowerment, nor like anything else. So I just think, I feel like that part gets lost a little bit in all this too.
Yeah. If I may add something to the inspiration part and using other artworks, I will just here quote a comment from a conversation I had with a painter, a fine artist who does like really traditional paper-based work. And like we were talking, she was trying to understand what this whole AI art thing is about. And she asked me, how can you say the machine or the algorithm creates artworks or generate artworks when it has not been trained on artworks, but on images of artworks? So what it creates, what it learns to create is an image of an artwork. It's not the artwork. And I have to say this question kind of shut me up. And I was like, yeah, you may have a point here. I was thinking this whole idea of the artwork itself versus the image. Of course, maybe that's a bit more touchy, more this difference is more related to fine arts and maybe a bit less to photograph, as you in the example that you quoted, Leah. But in terms of copyright, this also adds a layer of complexity because, you're not feeding the algorithm with the actual Van Gogh painting. You're feeding it with an image of the Van Gogh painting.
This is mind-boggling.
Sorry?
This is mind-boggling.
Yeah, it adds a layer. And then who took the photograph? And then do you need also to include this authorship of the photographer of the painting in the attribution? So I don't know how this is going to evolve in terms of legal and protection of these rights. But what I would imagine is that we would get closer to something like laws around plagiarism. That is because, as you said, Leah, and I think it was Nigar as well, artists and creators have always taken inspiration from others. And Nigar, you mentioned the issue of cultural appropriation. I think it's a bit the same, that creators also have been taking inspiration from other cultures, from other artworks, everything. What creates a problem is that when the output is actually so close to the input that it can pretend to be a replication of the input, and like when this is when it gets to plagiarism. And so I would assume that the laws around creative AI would be similar to the laws that protect authorship against plagiarism. This would be my bet as to the direction it would take, because I don't think you can control data sets and use of data sets. And like, what if I went to the museum and photographed, like I paid my ticket and then I took a picture of everything in the museum? Like, of course, I should be allowed to feed my algorithm with this. And so I think what will matter will be what you create with it. This would be my bet on how this will evolve.
May I take from here over one thought, maybe? Thank you very much. And because you put up one issue, I think that leads into a discussion that is more focused on the art historical or art theoretical questions around that. And as you said, well, it's a picture or a photograph of an artwork and so on. So that leads to one question that I had, or I always had, but it also came up when we had the first day, the presentation of Ahmed El Gamal, and that's like the question is, we have been talking in AI art a lot about style, you know, like style was something that somehow the machines could learn very fast. With machine learning, and so it's all about the style, but that's not like that's the you know the difference between the artwork and the picture. Maybe there's something of the same in the word of concept of style. Yeah, it's a surface. So yeah, you're using this superficial notion of style, but how can we judge the artwork itself? So and that has come to a very complicated situation. Maybe not. That the question is now, how can we, what is the criteria to judge on AI art, and what is how can we do that? So as from a perspective of an art historian, that I'm not, you know, I'm an artist, but do I need to know math, you know, to judge about the quality of an AI art, or is that of no need because I can just judge upon a style? Yes, a habit of style. So I would maybe if that was somehow clear, I would like to hand that over to maybe Isaac to think about the question. I mean, what makes the AI artwork an artwork? Yeah, that would be nice, Isaac.
Thank you, Christoph. I think that's a very interesting question, and if we were to think from strictly a formalist perspective, of course, it would be possibly not able to be answered by somebody who, like you said, doesn't know mathematics. I suppose we could look at the attitudes, the sensitivities, and the concepts behind the algorithms that went into the art, or the way that the artwork is deployed, channelized into the world and encountered by others. I mean, we can ask this question about any kind of so-called experimental work of if art is simply the process by which the perceiver and the perceived change each other in time, well, that means art and life are not different, except for in the Duchampian contextual sense. However, but we can ask, what happened? What happened when the artwork was deployed into the world? What happened when someone encountered it? So it becomes less a question of technical skill, right? And more a question of magnitude or impact. I want to respond to Celia's point too, in this vein, because I'm really interested not only in how AI is changing how we make artwork, but also in what ways will it change how we hear? Like AI produced music, will it change how we hear? Will images produced by an AI change how we see? I mean, if we think back to the turn of the 20th century, when we saw the invention of electrical devices and long distance communication, this gave rise to a widespread interest in seances and mediumship. And this in turn then influenced the practices of many poets, for example. William Butler Yeats has an anecdote about taking dictation from his wife who is speaking with a ghost on a train, and so on and so forth. So Celia, back to your point, thinking about the impact of AI going in the other direction, not necessarily the artist going into the AI process, but the AI process going out into the world. I think it's really important that you're pointing to mediation, because a lot is at stake in terms of how not just the artworks are mediated, but we are mediated, right? Just to give you an anecdote, I have a friend who's gallerist. As the artist was working on a series of works, asked the artist not to make the works all black because they were impossible to photograph, were very hard to document, and thereby, picture via Instagram. So you could argue already that the mediation via Instagram changes the aesthetics of some painting, because some photographs better than others. And furthermore, the qualities of our mediation even reshape our bodies as people get plastic surgery in response to the angles of cameras and so on. So I'll leave it there. But generally speaking, I'm interested in, I guess I would like to ask the group which new feeling intensities, behaviors, aesthetics, superstitions might arise en masse. Now, how will artists respond to this? Artists at large and also artists working with AI, if you were to speculate.
Luca, can you comment on that? Like, you have spent years and years on curating a lot of AI art and looked at these technologies. So what are your thoughts and perspective on that, Luca?
So certainly kind of, my thoughts on kind of what makes an AI artwork valuable, or how to kind of distinguish them is, so I guess I always, try and see what people from different sides of the community are doing, because I think the type of art that, scientific researchers can be quite different from kind of fine art trained artists, and also kind of new media arts graduates. So everybody's been making like quite different art. And I think I've always tried to judge it across at least kind of, one category. So one would be kind of the aesthetics. So what does it look like? Is there kind of innovation or something interesting done in the way the image looks? Because I think quite a lot of people from the technical community focus on that aspect. And then the other side would be like looking at the concept, which is where I think a lot of the people from the media art community might be kind of very strong in, because that's what they've been kind of taught to develop as part of their work. And I guess sometimes both of these are great, but frequently it's kind of been one or the other that's been like particularly strong. And in the types of kind of projects I do, I try to certainly foreground the work done by the technical community, because at times I felt that's been a little bit underappreciated. But I think it's good to see a mix of people's kind of interpretations and ways of working kind of with AI, because of course not all of it is just kind of, generating kind of images, or not all of it kind of makes its way into the final product. Some of it's used as kind of inspiration or like other ways. So that's my thoughts.
I want to add a comment on one of the points that Celia mentioned. So you talked about data and data sets creation. So one of the aspects that I think might be interesting to see is that, like, if we, like, part of our concern is coming from the fact that we don't know what those data that was created, like what was the mediums on data creation, what was the previous life cycle of those data. Maybe that data was also created by another artist. So I feel like because data sets is something that we we create, and then not only ourselves will use it, maybe like so many other people were also using those data sets. So I feel like documentation of these data sets would be very helpful to just having sources of contact, like just manual documentations of everything that we do with creating large scale data or data that other people will use for creating other art forms of art. That could help, like in like before like having all these policies around or having specific rules. Like if we can have some documentation which shows what's the origin of these parts of data or art, like that could be also very, very interesting, I feel. Yeah.
I think this focus that everyone here has brought out on data sets, I think really matters. And I'm often reminded of this quote from Jared Diamond, who wrote, you know, the price that we'll pay for not annihilating ourselves with nuclear weapons is complete cultural homogenization. And these data sets and the tools that we use seem to be pushing us toward that, right? That, you know, all of the language models are largely based on English writers on the net. And there aren't good text-to-speech engines for Swahili or, you know, the languages that don't have great data sets that are supporting them, that are allowing those things to come into being. And what I worry about is there are actually very few great data sets, and there are very few great APIs that have the scale to run them. And hence, whatever cultural biases that we have that led to that creation, actually, I think will get reinforced. And then I think to Isaac's point, then the medium affects so much of what people need to do to make a living, to gain status and put out there, that all of those things, I think we have to be extremely conscious about trying to push in other data sets and other perspectives that we haven't digitized well. And if we don't do that soon, I think those subcultures will in time be annihilated within a generation. And I think there's a real risk of that.
That's an excellent question. Like how to approach the making of these data sets in a way that is representative, not just of the average. I mean, I'm thinking a little bit of the so-called Gangnam style problem that YouTube had a couple of years ago, when that was the most viewed video. And if you just let the algorithm run and choose the next video and the next video, all paths led to Gangnam style. So they responded to this by making the recommendations be actually super like what you're looking, but more niche or more obscure. And there are those who argue that actually the popularity of certain conspiracy theories and forms of extremism are partially related to the fact that you get these more and more niche recommendations as well, on the other hand.
This is really interesting. Yeah.
Go ahead.
No, I was just saying this is really interesting, like how like this two ways of thinking. Either you go fully mainstream or very niche, like as if like you have to direct it either way. I find this really interesting as a thought about culture.
It does remind me of a story I heard of. There's this guy that was the director of AI for Lowe's, which is a hardware store in America. And he got a call from one of his store managers about, you know, there was an AI algorithm that recommended which products to place at the end of the aisles. They're called the bookends at store. And they're like the impulse purchases. And the store manager called him up one day and he's like, hey, why does your algorithm keep telling us to put together meth kits at the end of the aisle at Lowe's? Right? So like everything that you need from the hardware store to build your own meth lab, that's what they kept putting at the end of each aisle, because that's what the algorithm discovered people need to buy together, and they often did, right? And so if we don't intervene, right, then clearly many of the worst and niche parts of our humanity will come out from those APIs and those algorithms as well.
Then how do we mitigate these biases? Let's say we talked about these technologies in language, in like the GPT we have seen impressive demos in the context of like chatbots and also games, right? But we know that also GPT was trained on a large corpus from news, and this news could be fake and things like that. So how can we act on this to make future systems less biased? And maybe you can have a conversation about what that means in chatbots, what that mean in art, what that mean in fashion.
Yeah, on this for now, I would I would totally agree with Sean. Like, we need to intervene at some point. I see it like on a simple example in fashion, in the work I do with visual. So what we do basically is we create virtual try-on solutions. So we allow any like a fashion consumer on an e-commerce website to choose a model that they identify with and see the clothing on that model instead of the standard fashion model, which is usually a tall white person. So we trained, like, we got the largest data set we could of like clothing and the clothing worn on a model, like these pairs, and we trained the models on this. And at first, like a few months ago, we realized to our horror that our model was not very good on fat bodies. That when we wanted to see the clothing worn by a fat model, the result was, yeah, like glitchy and not very nice. And this was very disappointing because this was basically what we were selling. This was what we wanted to showcase the world. Like, what we want, the product we wanted to create was a product that would be able to dress any human body. And we were just not able to build it properly because the basic data set was not good enough. So we had to like go back to the data set, go back to the training, and like curate, really like fine tune, add more plus size fashion lines, whatever. Like we had to go, like, it was not as simple as we had thought, let's say. And so we had to go back to the crafting of the algorithm to make the product serve the purpose that we wanted it to serve. But this was, yeah, like a typical bias problem, like typical data bias problem. So yeah, I would say intervene and like check that your algorithm is not biased.
We should acknowledge that's inherently political. Right.
Yes. It like it's just what it is. Like we need to acknowledge that that we have to be careful and that we have to check and that we have to manually intervene and tweak it, because things will go wrong. And AI is not magic, and it's just a fantastic tool that helps you go faster on a lot of things, and but it's still just a tool, and yeah, garbage in, garbage out as usual. So
yeah, building off of that, I also want to highlight that like what is bias and what is not is also a very subjective question depending on who's making the judgment call. And so like, yeah, like you as an individual might think like, okay, I'm looking for this, but if someone else in your shoes who like came from a different background were in your same spot, they might have a different idea. And so it's also important to have like diverse teams behind all of the development of the technology. So that it's not just like one specific demographic that is making the call of like, this seems good, like we'll put it out.
I have one question to that. So would it be possible to create a network or AI that would have no bias? So that would be, in advantage of any human who is, as far as I understand, somehow ever influenced by his, her, its own bias. So what would happen if this AI would be without bias? What do we think about that? Is that really something that we want to have? A superhuman AI?
I believe it would be impossible, and the people in power would then tell you it's unbiased, and it would clearly be biased.
I agree with what Sean said. Like, I mean, I feel like unbiased towards what? Because like if you're unbiasing a system with respect to one attribute, it could bias the system towards the other attribute. And it's like very hard again, like to draw a line that this model is unbiased. Like, so it's very important what to specify exactly what are the priority of the system. If you're going to unbias the system, or like I won't say even unbiased, I would say like reducing the biases of the system towards one system. What's the reason that we are considering those as priority of the system? And also continuing what Celia and Leah mentioned about this, like this biasing against, like, I mean, Celia mentioned biasing over against like overweight people, people with higher weights, and Leah mentioned like biases towards which community. I feel it would be great if in applications, in productions, in things that matters for a lot of people, to involve people who are impacted by those technologies. So not just like having a group of people thinking about finding all biases or like some biases, but also involving and bringing in people who would be like directly impacted by those technologies, people from different demographics, people with different sizes and weights, like in fashion industry or genders. And then see how we can prioritize those issues before going to make the system like very perfect.
Yeah, on this, I saw a few months ago a very interesting presentation by some philosophy students who were researching on the topic of data labeling and the impact it may have on on biases in the data sets. Basically, the starting point of the research was, would it be useful to bring back the some of this data labeling work, which is done overseas, usually in very there's a lot of it that's done in Southeast Asia, and it's very centralized in some areas of less privileged countries. And they said, would it be the starting point was, would it be useful to bring this back to the Western world? How would this impact diversity and diversity in the labeling, in the data? How would this impact biases? And what was really interesting, it was at the end of their research, their recommendation was to not consider labeling as a job, but as a task, and to spread it along the value chain of AI making. They were saying this should not be a job that's allocated to a specific type of population. It should be done by everyone, basically. And of course, this was a not very applicable recommendation. It's very hard to put it in place, but it made me think a lot. And as these were philosophy students, so their recommendation was not meant to be an actual action plan, but it was really interesting to think, data labeling is such an important work, and it's such an important foundational task in the making of the data sets, the making of the models, and hence all the results of what will be made with the AI, that it's interesting to think of it as so strategic that it should be done by everyone and not just by a section of underprivileged people who are then reacting to pressure from mainstream and power structure and existing power structures, etc. And I thought this was really interesting to see it that way, and to see it as so central that it should be done by everyone in order to make it diverse and impactful.
Yeah, maybe one thing I'd like to add, I would like also to share with you from from machine learning research perspective, and I think maybe Nigar can also add to that. This is a very exciting domain also that the machine learning community is excited about. How do we mitigate bias, and how do we I would say formulate teaching signals for machines so that they perform well on both men and women, and I would say both so that they perform well, let's say, based on white and black people. And the way this is being done, for example, is to just have some to stratify or to group to define the groups that based on which we want bias to be alleviated, and just encourage them all to be as accurate in all these groups. So check the performance of a fashion or a fashion model, for example, on the group of based on groups of based on the weight, for example, of some person, or based on the gender, and check the performance as you change from one group to the other, and see. And that way we can measure. Let's say this could be one way to measure the bias, but this is not, of course, not the only way. But one way that we do to explicitly mitigate this bias is to add to the neural network that teaching signal, that if we feed you images from that group, you should be as accurate as your prediction of accuracy should be as accurate across all groups. And maybe Nigar, if you probably have know more about this perspective, you may add to that if you like.
That's a very difficult question, actually. Like that's like how to mitigate, or like how to make sure that the systems are not biased, because like first, I mean, it's again like it has like multiple layers of complexity. Even like definition of biases in different systems is very different. Like how we can define like if this system is biased towards which group, which demographic. And I feel like one of the aspects that I think is very important is also like involving this kind of considerations in all layers of power structure. Like what's the demographic of this research group who is working on this problem? I mean, in my research group, maybe like no one is like really thinking about this as an issue. Maybe like since I don't have anyone from this demographic group, maybe like this question is never coming up. Like I don't know if you've seen that work from Joy Bulumvini, Coded Bias, and also the Coded Bias documentary, that she was talking about the fact that like her face was not recognized with this face detection systems back then when she was a master's student at MIT. And then when she put a white mask, the system was able to capture her face. And this was not diagnosed before her because there were not enough people who were testing for those systems whose skin is dark. So it's very important like to have this people from multiple like demographics into the power systems, and also to be able to identify what are the things that are considered as bias to be able to mitigate for them. Also then in data collection, power is a very important aspect. So who is collecting this data? Who is the labeler? Like, I mean, Celia mentioned about the labeling aspects, like why are the fund which is spent on labeling is not as much as it should be. And also like another factor that I learned during the last year, because I was working in a group which was like very, had a good diversity and inclusion aspects, was that we also need to have like socio-technical researchers working with us, because sometimes there are some biases or some stereotypes that are rooted in society, and how we can identify them, how can we mitigate those specific biases. And not everything could be like very generalizable. Like we can't say that we will be solving these biases for this specific task, and then it would be generalized for all other tasks or all other like retail issues or other kind of tasks like object detection or other problems that we have. So it should be very, very task specific, application specific. So yeah, I feel it's a very complex question and very interesting one.
Thank you, Nigar. I would like also to encourage the audience, if you have any questions for the panel, you can feel free to raise your hands and ask question. So yeah.
To pick up on Nigar's point, though, of like there are some forms of bias that are in society that need to be, I think, handled legally, right? In terms of, like, let's imagine a facial detection algorithm used in a retail store, right? Then it's very possible that that retail store may figure out that their most profitable customers are white dudes. And hence they should really optimize to spend all of their sales energy on white dudes, because historically that has been the way to maximize their profit, right? And you can imagine all sorts of systems that are being built for companies that are effectively doing the same thing when they're doing lead scoring on incoming e-commerce sites, though it's not quite so clear.
right? And we may come to simply say, that's illegal, right? We don't want to basically reinforce that power hierarchy that said that for basically, yes, you know, these people in the past with these easily detectable traits, right, happen to be statistically better buyers for our product, and hence we should give them sales. And so I just think we may get to the point where we say that certain types of labeling and certain types of attribute detection based on, you know, codes that are in constitutions all over the world, you're not allowed to discriminate on the basis of race, gender, everything else, that we may say that those have to be put into our systems as well, right? And it's not just a technical decision, it's also a political decision that we as a society make to say, no, you just can't do this. It may be technically possible and we may try to address it, but we think it's wrong. And then it gets to the, you know, a fight of like, well, did the Republicans versus Democrats win that year? And thus, you know, is that law going to pass or not? Again, it comes down to, you know, as I said, inherently political decisions. But I do feel like all of these algorithms are largely reinforcing existing power structures. And if we want those power structures to continue, then we can leave the bias. But if we want them to change, we're going to have to intervene.
There's a question to Luba again. Luba, what's with when we talk about quality, what's with the criteria of Instagram followers when you are curating an exhibition? Do you look how much people follow an artist?
So personally, I don't even actually think of Instagram, because a lot of the artists who kind of work with AI, some of them come more from a technical background and they're actually more active on Twitter. And I think that's actually a platform where I see a lot more kind of AI art. And I don't tend to look at the number of followers because I know they can be bought, right? So yes. It's just very tricky. And there are some artists who are, I think, like very successful in AI art, and you look at their Instagram or Twitter follower accounts and they don't actually have that many. They might even have like a few hundred, but they are probably the more important artists in the field. So yeah, it's not really a criteria I look for.
Thank you.
All right. Do you want to comment on NFTs? I think it's kind of related, and it's an exciting topic that has gained a lot of interest in the past several months.
Oh yeah, NFTs. Yeah, they've sort of like dominated my newsfeed a bit this year. I think together with kind of Clip and Dali and all their generations. And yeah, no, I think NFTs are great because they've enabled a lot of the digital artists to kind of sell their works and kind of provide different ways of kind of allowing more people to collect it. And so I know there was, I think, a peak of interest in kind of March, then I think maybe it slowed down, and I would be curious to see how it develops kind of in the medium and longer term. But yeah, it sounds like kind of a lot of the artists managed to, a lot of the artists who've been in the field for a while, they've managed to, I guess, sell their creations. And there's been a lot of kind of newcomers who always kind of come as soon as there is a trend. But yeah, I think it does present a lot of great opportunities for kind of artists, and I guess I'm just curious to see how and if it will kind of stay for the longer term.
Isaac, do you want to comment on that?
Sure, yeah. I've also been reading a lot about NFTs, and I was invited to sell a work via NFT, which for reasons I won't get into now, I chose not to at this time. but I have no major objection to NFTs. I think they're great, actually. And I do think that the most interesting works are yet to come. I think that especially the capacity of artists to stipulate a smart contract that goes with the sale of the NFT may open up a lot of interesting possibilities. I mean, I'm thinking of Yves Klein selling Gallery Air. I'm thinking of Duchamp's Monte Carlo bond. Like, what are some interesting moves you could do with the smart contract part of the NFT? Would be some territory that could be worth exploring. I think too, there is sort of a gap right now, a little bit maybe, between many of the people who are really engaged in buying NFTs, as people probably know, are people who have a lot of cryptocurrency and might want to diversify. And many of those people may not be necessarily engaged with the field of contemporary art. I don't see any inherent problem with that. People should like what they like and buy what they buy. But I think that there are also interesting possibilities for something like a hackathon or an incubator type of event where you bring together somebody who's, you know, thinking creatively from the crypto kind of sphere and somebody who's thinking creatively within the contemporary art field, and just see what they come up with. I'm smiling at Sean's comment there. Yeah, diversify equals change crypto assets without taxes. I mean, I guess that art collecting has been used to avoid taxes for quite some time, and just one more flavor of that, I suppose, too, in some cases.
I mean, the only comment I would make is that my greatest hope is with NFTs that there are more people in the arts that make a living, right? And I just think, especially with COVID, so many sectors, especially in the performing arts, have just been crippled, and you just have people leaving the field. And so if there's a new way for livelihood generation to happen in that field, I think it's inherently good. It's a weird place of rampant speculation, and and also, the art market has always been filled with people that are manipulating things like a cartel, and we've formalized all of that, right? Like, all of these things are mostly in it just so that they can buy assets and bump up the price of their own assets so that they can continue to do it. And so NFTs to me represent these weird confluence of like the hyper computerization of finance with a little bit of art, right? That's happening as a sideshow. But if more artists can make a living, I don't view that as a bad thing.
Quite right, quite right. I should add one more thing that could be interesting, in my opinion, is the way that these NFTs are being purchased and displayed sort of creatively in the metaverse, which often we're used to seeing digital works. I guess at the beginning of the pandemic, it was, okay, let's have our exhibition as a virtual show and let's make a white cube. Let's render a white cube and put things on the walls of the white cube. But if you look at the ways people are exhibiting the digital works they acquire in the metaverse, it's quite a lot more inventive. I wonder if that can then in turn radiate into ways of installing works in the material world as well, and churn up some new ideas.
I think we have one question from the audience. Shaima, I think, please feel free to go ahead and ask your question.
Yeah, so I was thinking about previously when you all were talking about how we should cite the data set, or if we use a data set from someone or their pictures, then maybe we're generating something that must be cited by that person. But as humans, whenever we generate new art, it's always inspired by something we've seen or a location we've been to, and it's based on our experiences. And when we input that data set into a machine learning model and it generates new art, especially if the art was that it learned on was not one specific painting and we're not overfitting, then in my opinion, I don't think it's a copy of art that has been, it's like a new creation. It's based on something we've seen, but it's not like stealing someone's idea, you know, it's not plagiarism, in my opinion. But what do you guys think?
Can share how I feel about this. Like, I think this is true that like we can also get inspired by other artworks, and it's just like where this line we can draw this line, like how much of this is like it looks like inspiration, how much is this is like memorization of the network, because generative models could actually go and memorize some parts of the other artwork and just generate the same thing as part of that new generated art. So where this line is drawn and what are the regulation is like, I mean, like having more transparency about the process of data collection, the data that we are using could be helpful to see and check, like maybe manually, like how much of this is a copy of a work that was there, or how much of this is actually just like inspiration for this newly created art. I think it's a very important question. And as I said, like I don't know the answer about this line, but I feel like there should be much more conversations around this topic. I would like to hear like if anyone else have.
Yeah, definitely. Thank you.
I mean, I'd like to make sorry, go ahead, Christoph.
Oh, I maybe I'm still on the other track. So I just wanted to add a short impression I had on this NFT discussion, because it just excuse me for being that naive, but I had a feeling that it was just opening up my eyes on a possibility to really establish like a ecosystem for the arts. So that there was like a missing stone somehow, that without the possibility of having whatever economic system in the digital space, a lot of artworks still would have gone in they didn't really find, or would have found their place in this digital space that we already inhabit as artists, as people, as anything. So I think with placing this and giving it a space and a possibility to somehow being linked to whatever financial interest that is, somehow close the circle for me in a long evolution of immaterial arts, of digital art, of social art, of participation, of producing artifacts that we have left the museum space for such a long time as a contemporary artist, I would say. And where are these works? They are hard. Speaking from my part, my position as a conceptual artist, it's very hard to get let's say a market for a lot of artifacts that artists are having produced in the last 20-30 years. And that doesn't have to be specific digital artworks, but even other artifacts. And they somehow now seem to have a place where they belong. And that was, so for me, it was intriguing with this NFT discussion that I just came up like last year, end of last year. And I thought that really made sense to me. I just want to add that to that discussion on the NFT space. Yeah.
Right. Thanks, everyone. I just want to say that what I feel now, what I feel now, I feel really amused about all the rich perspective that we have brought to this discussion, from coming from covering things like AI bots, fashion, virtual reality, sound, music, and all of this amazing stuff. And I just want to share with you that the goal of this kind of conversation is to, I think, to have more engagement between AI research and artists, and that perspective made these meetings really so much enjoyable for me. I'd like to thank all of you to contributing to this experience. That was so much enriching for me, and I believe for many others here. So I think these conversations, I would say, I would love to do it more and more. Yeah, thank you for your contributions to the panelists and for the audience. And yeah, with that, I think I would like to thank the audience and everyone. And
one important
yeah,
thing.
I want to say something. Yeah.
Yes, if we would have been on a physical in-person panel now, I think we would have some flowers or whatever to hand them over to the facilitators of the 3-day symposium, which are Arnab, Isha, and Sarah, who have done an incredible job, in organizing a lot of stuff in a very short time and making that happen, which I never believed would really, work that fine. So thank you both, you three, and maybe I missed someone. So if that is I'm going, deeply into my, but thank you all for making that happen. So thank you very much.
One final note is that just a gentle reminder, we have a social event on GatherTown if you're interested to connect with others in GatherTown. We have that announced on the web page, and also we like to encourage you to share with people if you are interested to submit an artwork. We have a deadline for the hackathon on September 17th, and the prizes and the winners will be announced on September 25th or something. So thanks so much for being a fantastic panel, and also thank you for being a fantastic audience. Yeah, and hope that we have more these discussions more often.
Absolutely.
I want to say thank you from my side as well. It was really an incredible experience. Hosting you all and listening to you all, like my inner mind is exploding with inspiration and thoughts. So thank you all so much. And since you mentioned flowers, these are virtual flowers for you all. Thank you so much for being here. And of course, thank you so much to Christoph and Mohammed. I think that the SAAI Factory is going a good way. So it's incredible. Thank you all.
Thank you. Thank you so much. See you. Bye-bye.
See you on GatherTown, hopefully.
Bye.